Hey guys, I welcome you all to the live session on MongoDB full course by Intellipaat. This session is conducted by multiple experts who will be teaching you everything about MongoDB from basics to advanced level. Before we begin the session, make sure to hit the subscribe button and also like our videos so that it will motivate us to come up with more such live sessions in future as well. On saying that, let's see the agenda of the day. Firstly, we will begin with what is Relational Database Management System. After that, we will tell you the types of databases and their limitations. Once we finish with that, we'll move on to what is NoSQL and its features. Then later on, we will learn about what is MongoDB and what are the benefits of it. Post that, we will learn about how to install MongoDB and MongoDB Chef. After that, we will learn about different data types in MongoDB. Then later on, we will tell you the most important topic of MongoDB, that is crud operations. Post that, we will tell you the difference between SQL and MongoDB. Then finally, we have covered a quick hands-on demo on how to create a login form in Pythonflask with MongoDB as the database. So, this is the agenda of the video. Without any further delay, let's get started.
Well, what are the prerequisites that you require for going through this MongoDB course? A very basic understanding of what exactly is a database. I'm sure you must be working with a database almost on a daily basis if you're working for a software company. Microsoft Excel is actually a database management system, but remember, it is not a relational database management system. Well, let us see what is a database. Database can be defined as organized collection of data. Although when you use this term database, you refer to the entire database system, the system that handles the data, not only data, but transactions or problems with transactions or any other aspect of the data. And this whole configuration is termed as a database management system. Now, earlier designs and implementations were based on the use of linkages or sometimes called relations between data and with specific other form of data. But these models were not standardized. They required extensive training in order to make efficient use of that. Now, what is a relational database system? It uses the notion of databases separated into tables where each column represents a field and each row represents a record. This notes will become more important for you as you go through this course as a reference when you are attending for an interview or when you're making a career shift or when you're writing a certification exam in MongoDB. So a relational database uses the notion of databases that are separated into, tables where each column represents a field and each row represents a record. Okay. Now a simple example is an Excel where you can see these are all this is basically a table which consists of all these columns and then these rows. This is a database management system, a DBMS only. Another example of DBMS is Microsoft Access, but it is more than that. It has got a primary key and also a foreign key. Okay, so a relational database uses the notion of databases separated into tables. Now this is only one table. Like this you can have many tables. If I configure this as a table with employee ID, then address, then gender, then phone, then email. Okay, this is one table. Let us say a table 1. I can create another table, and by saying here I would say status or the employment status, whether he's still on rolls or permanent or contract and so on, the employee first name and the employee last name, and then you have the employee ID. Let's say you have an employee ID of 1 with an address XYZ for now, gender female, phone in this format, and an email @z.com. Okay, this is a random email I just created. Now here you have as a permanent Frank and then Smith and then 1. The same employee, Frank Smith, who has got the employee ID of 1, has this address, gender, phone, and so on. Now what is the relation between this table 1 and table 2? Now imagine this at a very micro scale now in this Excel sheet. If you expand your imagination for a multinational company where employees' records for payroll, for compensation, for HR, for sales, for so and so, for the performance review, for the number of sales or the quantity or the price of those sales done, whether he's in the finance department or accounting department, and there could be so many departments in big companies. How do they maintain such records? It's cumbersome, it is complex. How do they check from a different table whether this employee is staying in this address or in a different address? How do they make a relationship between this employee ID and this employee ID? So these are all the questions that we will look at in a larger way in relational databases, and particularly in Mongo also. As you can see here, traditional databases have organized collections of data. They have this notion of tables, different tables, and how they are connected. They have the concept of primary and foreign keys. And then there is a design schema. What is a design schema? If you look at this particular thing is called a schema, where you have 3 different tables. One is the users table with user ID as a number, username, the password, and the email. You have another table called purchases, the sale ID, item ID, user ID, sale date, and quantity. And then the items table, where you have the item ID, name, price, category, and a description. Now, an important design aspect of relational databases is the normalization of a schema. Now, this particularly involves 3 steps. One is called the first normal form, then the second normal form, and then the third normal form. But how do we arrive at these 3 different tables? We do something called a normalization of a schema. What is normalization? Normalization in plain English means making sense of the entire database. So it is the process of organizing the columns and tables of a relational database to minimize the data redundancy, so that we don't repeat the data in many tables. And how do we normalize this particular structure of let's say an invoice? An invoice, as you know, has usually an order ID. It has item ID. So in the same order ID or the form, you can have item ID 1, 2, 3, 4, and so on. You could be purchasing computers, accessories, mobiles, and so on. Now, when you have such invoices in large quantities, how do you represent those in the actual database in an RDBMS? So these are the 3 key steps that are followed. And the first one is the first normal form, which means there should not be any repeating elements or groups of elements. The second one is no partial dependencies on a concatenated key. We will look at what exactly it is. And third normal form is when no dependencies are there on key attributes. So have a look at this one. Let me just make it as a full screen. So don't repeat these columns. That's the first normal form. So you have your item ID 1, item ID 2. So 100 could be a Mac, a 101 could be a Dell, and so on. But they're all part of a single order ID, and the order ID is 1. So the way we do a correction of this is in this format. Order ID, which remains the same because it is for a single invoice, and then the item IDs, which is 100, 101, and so on. So this portion right there, these 2 columns, are done in such a way to reduce the redundancy as you would typically write in an Excel sheet. So we never repeat the elements or groups of elements in a single table. That's the first normal form. The second normal form is, as I said, no partial dependencies on a concatenated key. Now, if a column is not related to the primary key, then you should break out the primary key into different tables. Okay. Now here the primary key is order ID and item ID. How do you determine which is a primary key? A primary key, or a primary keyword in fact, is a key in a relational database that is very unique for each record. It is that unique identifier, which could be, your social security number, your driver license number, or a telephone number, or your vehicle identification number. These are very unique to you. So a relational database must always have one and only one primary key. So here in this case we have order ID as the primary key. When you have two primary keys, it's called a concatenated primary key. It's like saying a primary key is a combination of order ID and item ID. So this together forms one primary key. Very unique identifiers in a particular invoice. Now, do we really require order date here in this table? So an order always occurs at some time, but is an order date really related to the item ID? It's like saying order ID will always be the same for a given order. Order date will be the same for a given order ID because you have received the invoice on a particular date, and all the item IDs on that particular date will remain the same. Okay, so regardless of the value of the item ID column. So this means data duplication. So you denormalize. So the way we correct it is in this format. So we bring orders and order items separately, and we put order ID that is attached to order date. So a order date is not really dependent on item ID, but it is actually dependent on order ID. Okay, not on item ID but on order ID. In a single order ID you can have multiple items receiving on that particular invoice. So this is actually normalization. It's making sense of the relationships between the attributes of a particular table. And here an order ID and item ID, they together form this wonderful primary key. Okay. Now we are all trying to establish whether a particular order on a date relies really on a particular item ID. So it's not. So that's why we separate. And the third one is called the third normal form, which means no dependencies on non-key attributes. Okay. Now this third normal form is meant to cover the single column keys, which means you put all the columns that are not related to the primary key into a different table. Okay, so like example, order date, customer name, customer city, and so on. So this customer information can be really a separate table. So you pull out the customer name and other customer fields into a different table, and then you put a customer foreign key into the orders. So this portion can be in a different table, and then that particular customer foreign key can be put inside this particular orders table. So you're actually categorizing. The whole process is to make sense and make an order out of these tables. Now the other thing about the traditional databases, and it's a benefit also, is called the ACID properties. Now what are ACID properties? A stands for atomicity, this is consistency, I for isolation, and D for durability. It's a set of properties that guarantee that the database transactions are processed with a great reliable factor. Okay, so what is a transaction? A logical operation on the database is called a transaction. So we are making sure that all these transactions can be relied properly because of these ACID properties. Now atomicity means, without going into much details because this is basics 101 of the database, atomicity is either all parts of a transaction must be completed or none. Consistency is talking about the integrity of the database in preserving all the transactions. So you don't leave any invalid state after a transaction. Isolation is when a transaction must be run isolated in order to guarantee that any inconsistency does not affect other transactions. That's when you isolate a particular transaction. A durability is when the changes made by a completed transaction must be preserved. After transaction is completed, it must be preserved, must stay back in that particular database. So there are few traditional databases which many organizations use, like Microsoft SQL Server, Oracle database, MySQL, IBM DB2. These are some of the popular traditional databases that exist out there. So let's look at some limitations of the traditional databases. One is scalability. For large databases, especially those that are used for web applications, the main concern is scalability. As more and more applications are created in environments that have huge workloads, the scalability requirements can change very quickly and can grow very large. Relational databases, they can scale well, but it is when that scaling happens on a single server. So we call that as scaling up. Scaling up is when you have a single server where you had initially about let's say an 8 GB RAM, okay, and you're now going to make it a 32 GB RAM. You had the server size as 2 terabytes, and you're going to scale it up to about 16 terabytes. So this is scaling up a single server. This is good for relational databases, but when it comes to scaling out, when the capacity of that single server is reached, when you can't expand it anymore, and when you can't set the configuration or upgrade the configuration of the server anymore, then that's the time, that's the scaling out time or the challenge. That's when the RDBMS poses a challenge in terms of distributing that load across multiple servers. So the scaling out is basically you distribute the load across multiple servers, moving into so-called what you call as distributed computing. So this is when the complexity of relational databases starts to give you some problems at the scalability factor. If you try hundreds of thousands of servers, the complexity becomes even more. And these are not cheap servers. Every server that you maintain needs to be a very high scale, high configuration, memory intensive or compute intensive or storage intensive kind of a server. So this is one of the main challenge of RDBMS. The other one is data complexity. Relational databases can save structured data very well, but not unstructured data. Structured data you all know, which is strings, integers, boolean, float, etc. So these are all basically they come into the purview of the structured data. But think about music files. How do you analyze them? Think about image files, XML files, emails, and a good example could be a Facebook like. What data type would you attribute to this particular Facebook like? So these are all part of what you call as unstructured data. So as unstructured data keeps on increasing these days, the data complexity becomes even more in terms of handling inside the RDBMS. Then you have the broken keys. Sometimes when the keys fail, the primary keys or the foreign key connection fails because of these earlier two issues, then you have a database predominantly where there is no relationship that exists absolutely. Then in every kind of RDBMS you have to define the schema before you load. You can't load and then define the schema. So it takes up time, whereas in the other kind of databases which I'm going to speak about now, called as NoSQL, you don't have to define the schema before loading. You load it, you analyze it, even if you do not define the schema also it is fine. So that's where the biggest limitation of RDBMS is. These four: scalability, complexity of the data in terms of the structured and unstructured format, the broken keys of and the relationships between primary and the foreign keys, and then definition of schema before loading it. Now let's look at a non-traditional DBMS that's called as NoSQL, which means no relation SQL. It's a form of database management that doesn't have any relationships. This term was coined in 1998 by Carlos Trozzi. The data that NoSQL type of databases handle is more complex, and there are many NoSQL databases that exist out there. So NoSQL databases started gaining popularity in the early 2000s when companies began investing and researching more into distributed databases. That is why you have got many database categories inside NoSQL. Some are based on document stores, some are on key value stores, some are graph based, and so on. An important aspect of NoSQL is that there is no predefined schema, which earlier you have seen. One of the challenges of RDBMS is overcome by NoSQL. That is one. You have no predefined schema, and then the records can have different fields as necessary, and this is something called as dynamic schema. Many NoSQL databases support very advanced features like replication, and all servers, in fact, they execute the same transactions and synchronize the data. An important difference between relational databases and NoSQL is that they do not fully guarantee asset properties. It's because it's their deployment architecture, which typically involves having multiple nodes in order to achieve horizontal scalability and also recovery in case of any failure. So this deployment and synchronization is very, very effective. NoSQLs use APIs or query languages to access and modify data. They may also use the latest Hadoop MapReduce methods, which is used for performing a specific function. In fact, the popularity has ridden more on the wave of the big data. And there's a lot of confusion in the market as to what exactly is big data. Well, before we go into that, I can tell you some differences between SQL and NoSQL. The SQL databases are table-based databases, whereas NoSQLs are different formats like document-based, key-value pairs, graph databases, or column stores, etc. So, whereas in SQL database, you represent data in the form of tables, which consists of n number of rows. NoSQL databases are the collection of these same documents or key values, whichever, depending upon the NoSQL databases, which do not have a standard schema definition. SQL databases are vertically scalable, whereas the NoSQL databases are horizontally scalable. How do you vertically scale an SQL database? By increasing its horsepower of the hardware, as I said earlier regarding the RAM or the processing speed or the hardware, the storage. It's all about increasing the horsepower by vertically scaling up. NoSQL databases are scaled out horizontally by increasing the database servers in the pool of resources so that the load is distributed optimally. Now, SQL databases, they use SQL, which is structured query language. As all of you know about these things, SQL stands for structured. There's no unstructured type. The structured query language for defining and manipulating data It's quite powerful. In NoSQL databases, the queries are focused on a collection of documents. Typically, I'm referring here to MongoDB. They're also sometimes called as unsql. It's a kind of an informal word, which is unstructured query language, and it varies from database to database. There's no technical term like this, but it is what is informally referred to. SQL databases are MySQL, Oracle, and so on. Whereas in NoSQL, you have got MongoDB, you have Redis, you have Cassandra, you have HBase, you have Neo4j, and a host of other CouchDB, DynamoDB, and so on, which are all types of NoSQL. Another difference is for complex queries, SQL databases are a very good fit because it has got that query intensive environment. You use the where clause and so on and so forth. Whereas NoSQL databases are not good fit. So these are the key characters and characteristics of NoSQL data. Now let's look at why NoSQL is gaining more popularity these days. One is definitely because it doesn't consider the relationships that is there for traditional databases, and it helps in dealing with unstructured and large data sets, of the loads of which can be distributed across different database servers. Secondly, there's no schema required at the time of loading it. Some of the other motivations for taking up the NoSQL is not having to deal with impedance mismatch between the object-oriented approach to write applications and the schema-based tables and rows of a relational database. For example, storing all the customer order info in one document as opposed to having to join many tables together, resulting in less code to write, debug, and maintain. So that is one of the simplicities of the design of NoSQL. And then auto elasticity, which is you have better horizontal scaling to clusters and machines, which really solves the problem when the number of concurrent users increases for applications that are accessible via the web and the mobile devices. So using documents makes it much easier to scale out, as all the information for that customer order is contained in one place as opposed to spreading out into multiple tables. And these NoSQL databases, they automatically spread data across servers for load optimization without really requiring application changes, which means natively and automatically data is spread across a number of servers without the interference of the application, or the application to be even aware of the server composition. So which really benefits the data and query loads, because of the balancing or auto balancing that happens across the servers. Also, if one server goes down, it can be quickly replaced with, in fact, zero application disruption. So a lot of failover scenarios are taken care, including very high availability. And you have also finer control over the servers or the NoSQL data servers, which can be really added or removed without application downtime. Most of the NoSQL databases, they support data replication. They store multiple copies of data across the cluster, and so even if one cluster is down, it ensures high availability and specifically disaster recovery. It has integrated caching facility. It has a very simpler data model. It can easily capture all kinds of data that is related to big data these days. Big data is nothing but, it consists of four main characteristics. There are textbook definitions for volume, velocity, value, and variety of data. So the textbooks really define that if the volume of the data is increasing and the variety of data is different, which means it includes structured as well as unstructured data, and then the volume, the variety, and then of course the value addition of this data, that is there, that how much of the data is really valuable for us. But before that, it is also the velocity of the data, the speed at which it is coming in. The volume, the variety, and velocity have been traditionally defined as comprising of big data. Now people are adding value and also veracity, the truthfulness, the essence of the data that is actually coming up. And so there could be a few more V's also probably in the future. So if the volume of data is huge, if there is a lot of variety in the data, if the velocity of the data is coming very quickly, then you really have a big data challenge. For me, the four main characteristics are, some of them are included in this. Data increases continuously. Okay, what does this mean? You must have all heard about Angry Birds application on mobile. It's pretty old now, but let's take a very a popular application in the mobile. Any popular mobile application. When 10 people download it, the effect on their server, on the company side server, is not huge. But when a million people download it in a week, then the amount of load that the server has to take in a week really increases and puts a challenge on the server capacity. So one of the characteristics is data should be increasing continuously. And then the second one is data is both structured or unstructured. People also call semi-structured, but I would comprise it in unstructured itself. So unstructured data is what we have earlier discussed, and it is difficult to analyze. Okay, so let's say you have to analyze 1 terabyte of data It's not really easy to do that because of the unstructured format, and also because of the volume of the data, the velocity of the data that is coming in. Difficult to analyze within a certain tolerable time limit. If I wanted you to analyze 1 petabyte of data in 1 month, or let's say 1 week, it's huge. I mean, normal traditional databases cannot really do that. To give you an idea of how much is 1 petabyte of data, a normal Blu-ray disc, okay, which has a movie, high quality movie, will have about 2 GB of space for 2 hours of movie, right? So if you have to watch 1 petabyte of movies continuously, okay, then it will actually take you more than 30 years to complete watching 1 petabyte of movies continuously. So, and Facebook deals with about 400 petabytes of data every month.
Just a quick info, guys. Test your knowledge of MongoDB by answering this question. In which of the following is MongoDB written in? A. C++, B. Go, C. JavaScript, D. Python, E. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
That's the volume that they deal with, eBay, Amazon, and so on. So if Mark Zuckerberg asks you to give him the result of your analysis, which is how many people in the last 5 years have been using on Facebook on Windows, and how many have been using on Apple, the Mac computers, and where the usage is more, and he wants the result in the next 2 days or 1 day, otherwise you're fired, then imagine your problem then. But the advantage is such kind of NoSQLs, of course intermingled with powerful frameworks like Hadoop, really can take care of such as not only storage but also the analysis part of it. Okay, so if you go to a company and if they say to you, yes, our data increases continuously, yes, it is structured as well as unstructured, yeah, it is difficult to analyze, and also within a certain tolerable time limit, you can confidently say that Mr. X, you do have a big data challenge. Okay, big data is a concept. It is not a technical framework. It is only a concept. Okay, so big data, which usually consists of such kinds of structured and unstructured data, can be easily captured inside NoSQL databases, because NoSQL allows you a flexible framework that can accommodate any type of data, and that is not disrupted by the structure of the content or the changes in the content itself, because the document database of MongoDB especially is schemaless, which means you can freely add fields to JSON documents without defining those schemas. So there is no it is schema on read instead of schema on write. So you fill in the data information inside, and then it will give you you can read it after you can read the schema without really entering the schema on the write in the beginning. Okay, you can have different number of fields that contains a lot of combinations of data types. Also, speed is one big advantage of NoSQL. The data structures used by NoSQL, that is the JSON documents, they differ from those used by the traditional databases, making many operations faster than RDBMS, because you don't have to join the tables. There is no concept of join in Mongo especially. So at the cost of increased storage space due to duplication of data and so on, there is no really join that is happening. But storage space is very cheap nowadays, because you can buy commodity hardwares. So most NoSQL databases do not even support joins, so it becomes very quick to analyze, because in joins you have multiple tables, you have multiple where clauses, and all those filters that are there, whereas Mongo can give you a great advantage. In addition to this, the NoSQL databases usually use clusters of, as I was just saying, cheap commodity servers. So there is a huge savings on the cost, whereas the RDBMS tends to rely on the expensive proprietary servers, whether it's IBM or whether it's a Microsoft and any other storage systems. And also remember, the licenses for RDBMS can be quite expensive, whereas NoSQL is open source and it is free. Okay, so these are all the differences between the MySQL and NoSQL. NoSQL databases are being used more in big data and real-time applications. And those systems are NoSQL, people also call as not only SQL. Okay, not only SQL. To emphasize that it also supports SQL-like query languages. So Mongo and so on, they support so on top of certain frameworks, you can do your SQL queries also. But some reason that block the adoption of NoSQL includes the use of a very low-level query language, because SQL is a very powerful structured query language, whereas NoSQL doesn't use a high-level equivalent query language. So that is one of the reasons that people usually do not go for NoSQL. But nowadays it is not a problem. Many companies have come forward for that integration. So apart from that, there are not really big challenges for NoSQL. Some people complain about security, but hey, Linux is also open source, right? So, but a lot of people use it because it's community driven, and the security in many years has really increased a lot, and similar thing has happened to NoSQL also. The NoSQL's databases also use different kinds of GUI as well as command line interfaces, similar to RDBMS. As you can see, there are different types of NoSQL databases, where it's document based or key value based or column based or graph based. There are quite many categories. In the document based, MongoDB, Memcached in the key value, Cassandra more in column based, and Neo4j in more in graph. But overall, if you look at it, Mongo supports a lot of features. There are also a lot of GUI environments that help you to do monitoring and administration of your database systems. One of the severe limitations of relational database is that each item can only contain one attribute. So if you use a sales example, a customer's relationship with the company is stored as separate items in separate tables. So the customer's master details are in one table, the account details are in another table, the sales details in yet another, the bank loan details is in a different table, and so on. So all these tables are linked to each other through the use of relations like primary and foreign keys. Non-relational databases are radically different from this model. They allow you to store several related items in one row of data in the same table. Okay, a radical difference. I just like to write it here. A radical difference is it allows you to store related items in one row in the same table. Okay, and this row is not same as, I'm not referring to the RDBMS or the table kind of a row. That's why I put it in quotes. So in non-relationship, for each sale, each row would contain the customer details as well as their account, loan, and also a lot of other details. So if you look at the example here you have address, gender, phone, and email, and so on, right? So a similar example for NoSQL would look like, you have your XYZ, comma, female, comma, x@z.com, and 1 and 3237, whatever the number is there. This is a LA number, so say 63. Okay, so all these things can be contained in a single row. Okay, let me just wrap it up. So this is how it would look, whereas here you need to have one attribute per row. That's a radical difference. It would seem to be a superior method of storing data, well, each has its own advantages and disadvantages. So in this case, you have all the information of the customer, the employee here in this case, stored as one data record. Okay, and the customer's transactions would be stored as in another data record. Okay, it's a big difference here. Um, an advantage of RDBMS is that it has a way of ensuring that your business logic and the rules on top of the database layer still remain the same through primary and foreign keys. Whereas in NoSQL, that responsibility falls directly on the application logic. And few people are really comfortable leaving this just to the application. So they do try to use RDBMS because of this lack of enforcing business logic inside NoSQL. Because when it comes to web-based applications that use databases, rigorously enforcing business logic is often used as a top priority. So it is the ability to service large number of user requests, which are typically read-only requests. So on a site like Amazon, the majority of users simply browse and look through, the items, which is like read-only operations. Only a few of them really do transactions to, it's like a read and write operation also, their credit card information and so on. So we are really talking about billions of page views per day here. I'm sure the Amazon administrators are more interested in quick response time to ensure faster loading for the site's users rather than enforcing rules of ensuring balances between reads and writes. So that is the real challenge is the RDBMS's lack of scalability when dealing with specifically OLTP transactions. Okay, lack of scalability in RDBMS for specifically OLTP applications. Okay, or any, in fact, or any with lot of writes. Okay, which is the type of relational SMP architectures. This is where NoSQL really shines. They can distribute the data across dozens and hundreds of, even thousands of servers. Google and Facebook have thousands of servers, and with each server handling a small percentage of the total request, the response time is very good for each individual user. This distributed computing model can be built on top of relational databases, but it takes really a lot of time to implement, especially when there are a lot of writes. So that is OLTP. Okay, that's your online transaction processings. The relational databases, it really insists on the data integrity at all levels. Okay, which must be maintained, in fact, even as the data is accessed and modified by the servers. And this is also one of the reasons that non-relational is taken up as a choice for cloud computing and social networking and so on, because at the initial level, especially at the write level, it's not really required, but at the read level, it enforces the data integrity. So at any point of stage, there should be data integrity. So not, and the RDBMS has it at all levels and all stages, which is minimized by the NoSQL. So for high transaction loads, RDBMS really suffers because of lack of horizontal scaling, whereas NoSQL really shines because it can deal with high transaction loads and at half the cost of what you do in RDBMS with no joins and great data analysis. So please remember these different types of NoSQL databases. And also remember why NoSQL is quite popular. So integrated caching, simpler data model, and so on. So in order to increase a few more points, just to add here on the slide, in order to increase the data and increase the performance of the NoSQL, techniques such as caching is also used in system memory. This is very much in contrast to SQL databases, where this has to be done using separate infrastructure. Okay, so just a quick few more points here for you. So there is a speed factor, Okay, there is a auto elasticity, which means it can distribute the burden of the load across multiple servers. There is no schema data, and then it's a very simpler module also. Okay, so what is document based? What is key value? What is column? What is basically this? All these things mean. Let's look at document based database. Okay, the classic case, of course, is MongoDB. So the document-based NoSQL can be considered the latest craze. In fact, that is taking a lot of people by surprise, and with this pleasant surprise. So these document-based databases, they work in similar fashion to column-based ones. They allow very deep nesting and very complex structures to be achieved. So there is this concept of document within a doc within another document. So it's like a hierarchical structure of documents that you can have, and these are JSON kind of documents typically. And these documents, they overcome the constraints of the other kinds of databases. So any kind of complex and arbitrary structure can form a document which can be stored using such management systems.
Just a quick info, guys. Intellipaat provides MongoDB training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Retrieving a value of a record means getting the whole lot of it, and it goes for updates. The slight performance related issue can be there, but the powerful nature of it quite overcomes this weakness. And then you have the key value kind of databases. So in key value, you typically have keys with values similar to a dictionary. So let's say you have a word and its meaning or meanings. Okay, so you have your key and values. So there is no structure, there is no relation. After you connect to a database server like Redis, an application can state a key. So which means again, an example is employee ID, and then the value would be an integer, for example, a 42 or 41 or something, okay, which can be later retrieved the same way by supplying the key. These are used for quickly storing basic information, which are done after performing CPU or other kind of computation, memory intensive computations. Really, a dictionary is a great example that is usually used for key value, because it constitutes arrays of collections with individual keys that match the values. Okay, so you have, in fact, Mongo has come up from the word humongous. Okay, so it's been taken from this. So humongous is huge data and big data and so on. So that's why it has been used there. We will go into details of Mongo anyway. And then you have your column-based DB. In this, you have your example as Cassandra and HBase. These work by a little bit advanced nature of key values. Despite their complicated understanding that is out there, especially for HBase, for which the community support is quite less compared to the Cassandra. The column-based NoSQL really do not require a pre-structured table to work with the data. Each record comes with one or more columns containing the information, and each column of each record can be different. The earlier Excel example that I have shown can be done for column, where you can store integers, boolean, all in one cell itself. It has got multi-dimensional arrays, wherein each key has one or more key value pairs attached to it. So these are commonly used when the key value databases are not enough and you want to store very large number of records. with quite a lot of information in it. Column-based database is used when you have unstructured data and non-volatile information, which is if a large collection of attributes and values needs to be kept for long periods of time, then you can have column-based data stores, which will come in real handy. They're also highly scalable by nature, and they can handle a really lot of information. Examples are Cassandra and HBase. HBase is used as a data store for Apache Hadoop. It's based on ideas from Bigtable, and Cassandra is a column-based data store based on Bigtable as well as the DynamoDB also. And then you have something called the graph databases. Quite popular ones are Neo4j, which is a vast graph and document-based hybrid NoSQL that's written in Java, and that comes with different operational modes also. Neo4j is a schema-free, extremely popular and powerful Java graph-based data store. And these are also used when you want to handle complex relation information. They make it extremely efficient to deal with complex information such as connections between two entities, various degrees of other entities indirectly related to them. For example, you have LinkedIn, which is based on first, second, and third connections. It actually is based on the premise that you're connected to anyone in the world by not more than 7 degrees. So the representation of that in using a graph database really becomes easier. They also are very good in situations where you want some relationships to be involved, like modeling data and classifying some information on this type of data store. A good example would be the representation of a graph database in terms of the nodes. So you have one node which is connected to different other nodes. So for example, Alice has got these relationships with the 3 departments, and she belongs to all these 3 departments, and she has got this label. So a typical example would be of a database representation in graph database is based on. So each node in the graph database directly and physically contains a list of relationship records that represents its relation to other nodes. And these records are organized by type and direction and may hold some other additional attributes also. So whenever you run the equivalent of a join operation, the database just uses this list and has direct access to the connected nodes, eliminating the need for a very expensive search or a match kind of a computation. And the Neo4j is very highly scalable open source graph database that supports ACID properties also. It has high availability, and it comes with a web-based administration tool that includes full transaction support and kind of a visual node link graph explorer. It's accessible from most of these programming languages. It has its own built-in REST web API interface, and among the graph databases, it's the most popular graph database. Now let's look at some differences between mainly RDBMS and MongoDB, because this is what we're going to deal with in the future of this course. So MongoDB is a document-oriented database. It is not a relational one. The primary reason for moving away from the relationship model is to make the scaling out easier. And there are a lot of other advantages also. A document-oriented database, it replaces the concept of a row with a more flexible model that is called the document. You can have embedded documents, document within document, and embedded arrays. And so this document-oriented approach makes it possible to represent complex relationships with a single record. There are also no predefined schemas. A document's key and values are not fixed, not of fixed types or sizes. So without a fixed schema, adding or removing fields becomes easier. And this helps the developers in terms of making their development quite fast. It has got very easy scaling. These are the equivalent terms. So you have a database and then a database. Within a database, you have tables, you have collections in MongoDB. And in the table you have rows, also called records. In collections you have documents, also called as objects. Now here also you have columns or attributes, and there you call it as a field. So here you have joins, but there you have embedded links and so on. So it's used for scaling up very easily. It has got tons of features. It supports indexing, it supports aggregation. There are some special collection types. It also supports some file storages, which are easy to use protocols for large files and their metadata information. So joins are not there, and then complex multi-row transactions are also not there. It was purely a deliberate decision to allow for greater flexibility and scalability, because these two features are difficult to provide in basically a distributed system. So it has got very incredible performance too. So there are many benefits to this. As you can see here in the next slide, it's more or less RDBMS replacement for web applications. It deals with semi-structured content management with real-time analytics and high-speed logging. It also has got caching and high scalability. But before we proceed further, please remember and learn these important technical terms. So a document is a basic unit of data for Mongo, and is equivalent to a row, but much more expressive. And the collection is equivalent to a table. A single instance of MongoDB can host multiple independent databases. So that's a great feature. A single instance of Mongo can hold multiple databases, each with its own collections. Okay, and every document has a special key which would be represented like _ID. Okay, and this is very unique to collections. So every document has a special ID, and Mongo comes with a JavaScript shell, which is useful for administration, and there are a lot of other admin GUIs available. Like more popular that I use is Mongo Chef, that you can download and connect with your Mongo. So everything is based on this document. Okay, and what does a document have? A document has got a key and associated values. Okay, this document varies by programming languages, but most languages have a data structure that is map, hash, dictionary, and so on. So these documents are represented as I said here, are represented as objects. So I would say in a JSON format, Mongo for developers, and then here I would say welcome to this course from Intellipaat. Okay, this is the most simple document that contains a single key. Okay, so I would just say Mongo for developers, MFD. Okay, here to just easily represent it, it's called as MFD, and this has a value. This would be the whole of this value. Okay, and then you have got really good benefits of this. Why use MongoDB? Well, I was just sharing, SQL was invented in the 70s to store data. MongoDB stores documents and objects. Everyone is working with objects these days, and all these programming languages are supported in MongoDB. So we need databases to persist our objects, so why not store objects directly? That was the concept which led to MongoDB. So you have embedded documents and arrays that reduce need for joins and no multi document transactions. So a database is made up of multiple collections, and which are created on the fly when you reference for the first time. So you don't have to say create collection. As soon as you say db dot some collection dot something, the collection is created. It's at the same time as it is referred for the first time. Okay, so if you type in db dot collection, So the collection is actually inside the database. The name of the collection is db.test. So the test is automatically created as you type in. You don't have to say create test and so on. And a collection is a table. Again, going back here, database, collections, and documents. Is a table which is schemaless and contains documents and indexed by one or more keys. It can be created on the fly. It can be fixed size, or older records get dropped after reaching the limit. You can also cap the size of the collection there. A document is stored in a collection. It can have a special key, and it works like primary keys in SQL, MySQL. It has got embedded or reference-based relationships, and the document storage is in BSON. It's a binary form of JSON.
Just a quick info, guys. Test your knowledge of MongoDB by answering this question. Which of the following represent column in MongoDB? A. Document. B. Database. C. Collection. D. Field. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
A typical example of the document would look something like this. So you are defining something called a variable P with a special ID, author, the title. It's an open source, timestamp, tags, and then comments. Okay, you want to post it in a blog. So you just put a db.post is the name of the collection, and then you save this information of the document, which is P, inside this collection called posts. Let's look at how to install MongoDB. For that, you need to first go into the this website called mongodb.org/downloads. Once you are here, you can go to the download section, or you can just cross the scroll bar down, and then look at various options for Windows, Linux, Mac, and also Solaris. You will have these options to install Windows 64-bit. If you are using Windows 7 or 7 Plus, including Windows 8.1 or 10, use the 64-bit 2008 R2 Plus on your 64-bit machine. If it is 32, then you can directly go for this. This is an installer, MSI installer. Once you download it and you double click on that. So before you go there, what you would do is, let me just explain installation on Windows, and I will go further into other operating systems. So you download the MSI file, or also the zip file. So you have two formats in which you can do that. So three, in fact, TGZ and zip along with MSI. So I would recommend using zip file, because you can extract all the files into a particular folder, which you will be creating now, which is create a folder like this. You can just say MongoDB. Okay, and now bring the zip file into this folder and extract files here. Now create new folders, which would be data, and inside this data you will create two new folders, because this is going to be the database path. One is this one, and the other is the log. So now you create a text file called Mongo here itself in this particular location. Create a text file which is on the lines of mongo.config.txt. Okay, so inside this you need to copy some information which is going to be in this format. You need to bind your IP address, which is default 127. Port number for Mongo is always going to be 27017 by default. Okay, if you interview, somebody asks you what's the port number default for Mongo, it's this one. And this is the DB path that you are going to mention. So please note that you need to use the uppercase and lowercase exactly as it is. Okay. And then once you do this, save this file, save the file, and remove .txt at the end. So it would be only mongo.config. Okay, sorry, it's not mong but mongo.config. Okay, and then once you do that, open your terminal by in the administrative with the administrative privileges. So which is going to be your the Windows key plus X, and then you press the letter A. Okay, so now here go into this. So by default you will have C something and then system32. So but come into this folder MongoDB. Okay, and now from here you type in MongoDB.exe. Okay, hyphen config file. You are referring to the C drive wherever it is located, mongodb/mongo.config. Okay, now open a new terminal. Now what happens in this case, it's actually running the MongoD instance. So, and in the new terminal, go to the bin folder wherever it is located, depending upon the zip files and this folder structure that you have of these zip files. The bin will be inside the zip file. Okay, and then you type in Mongo. So it will come up with db and then like this test. Let's look at what is there inside. So what this does is it binds the IP address or addresses to MongoD. Okay, and this is the port where MongoD should bind to. This is set to be true so that only critical events and errors are logged. Not everything that you do in Mongo is really needs to be logged. This is where you store the data. Okay, and that's the path. This is the DB path actually to the where you store the data, and this one here is the path to the log file to which MongoD should write its log messages. Okay, then I have a log append to true so that the log is not overwritten upon the start of or the restart of MongoD. Okay, so this is written. This is true so that the log is not overwritten upon restart of MongoD instance. Okay, just take a note of that. Okay, so now let's look at how to install in Mac. So MongoDB installation on Linux. So you go to the same site, which is mongodb.org, and then you download the 64-bit or whatever 32-bit in your so in your case whatever it may be, and then you save it. Okay, you save the file to /home/ let's say downloads. Okay, so then you unzip in the same folder. There will be a zipped file, so you need to unzip. So the way you do it is by using a tar. You can have any flavor of Linux, Ubuntu, CentOS, SUSE, Red Hat or anything, but the command line will be the same. So basically you are unzipping the file, which is the tar file, extract zip verbose file xzvf mongodb -linux, and if you have this version, then whatever that version is, 3 point something .tgz. Okay, then you create a directory from the as an admin by saying mkdir/mongo/data, and from your downloads section, so wherever it is, downloads. Okay, from here you type in this one, sudo mongodb -linux -i686, the version that you are using, /bin/mongod, and then you give the db path as mongo/data. Then you will see that it is waiting for connections. I'll also give you the port number 27017. Okay, so then open another shell, and there you type in Mongo. So here, let's say you are here, Mongo-Linux some version /bin/Mongo. Okay, now it will say connecting to test, and it will give you the terminal like this. So you can insert a simple JSON file. You can also ask it to show you the DBS, all the databases that exist. You can say show DBS. Okay, then here as you can start using the MongoDB. Also, if you go to any browser, let's say Firefox for example, inside Firefox just type in this one, localhost with a colon 27017. Okay, it will show you the details of Mongo there. This is as far as Linux is concerned. And if you need to look at Mac installation, okay, in Mac also it is pretty much the same as Linux. So you download Mongo, and you click on your Mac OS, whichever stable release is there, then go to the download section or the downloads folder, and then type in the same thing, which is your tar xz. XVF also goes in Mac, so MongoDB something .tgz. Okay, so you will see Mongo and MongoD process here. So make a directory mkdir and p/data/db, and then give the permissions, all permissions, read, write, and execute permissions on this one /data/db. Go to the bin folder, okay, and then type MongoD. Okay, the port will listen to the 27017. Open new terminal, and then you type in this Mongo to execute that. So your MongoDB will start running then. So in my case, going forward with the examples, I have installed it in C, MongoDB, and then this data. Inside the data we have DB and the log files also. Okay, so this is the main structure, MongoD, data. And Mongo Chef is a GUI which I installed later, but this is important, MongoDB and this data and this DB and then this log. So this is what I have created. So instead of saving data in tables, MongoDB stores JSON documents. What is a JSON? Mongo stores JSON documents. What is a JSON? It stands for JavaScript Object Notation. Okay, so which will look like a key and a value. So you'll have like a name and then Frank. Okay, and then you can have like a fruit and an array, which basically the brackets are not correct, but I'm just typing in for example's sake, and then orange and so on. So like this you can also have, so fruit is an array of apple, pear, and orange, but this is not possible in RDBMS. Okay, really not possible. So the way you do it is, in fact, if I write it the exact way, it's going to be in this format. Okay, for fruit. So this particular thing is not possible in RDBMS. There are two basic data structures that are there in MongoDB. One is called the arrays, the other one is called the dictionaries. Okay, now these data structures are schemaless. As you have seen earlier also, when we looked at the benefits of Mongo, and the docs do not, which means the docs do not need any schema, right? So therefore MongoDB is a document oriented and has dynamic schema. It does not have joins, does not support transactions across documents, and it doesn't support SQL also. Okay. So which features does Mongo omit to retain scalability? which features does Mongo omit to have scalability? If I give you 4 options, which is indexes, joins, transactions across documents, storage. Okay, so it would be joins and transactions across documents. Okay, now let's go to the terminal. I'm just on my Windows system, so I'm pressing Windows plus X here, then pressing A. It'll ask for yes. So I'm now logged in as administrator. I'm going into the MongoDB. Okay, so MongoDB, and go into the bin folder. Right now, there are 2 ways to do this. One is by doing the MongoD space db path, which is this one right there. Okay, so you can type this, or you can go directly, or you can also do a net start MongoDB, because we have installed it as a Windows service also. Let's do it the other way, Windows service format. Okay, so what I'll do is net start MongoDB. So 3.2 version, which is the latest one as of Feb 18, 2016. I just started, and just type in Mongo. That's all. Okay, so it has connected to the test collection. Now you can say show DBS. It will show you that there is one database that is there, which is the local database, and we can start it in a different format also, where if you put in MongoD, it will say 271017 listening. Then you open a new terminal and then type in Mongo there. So then it will open the same terminal where you can have your practice sessions. This we have opened through Windows service. If you want to look at the help, then you can also type in Mongo and then help. Okay. Okay. So you can have just type in help there, and you can see a lot of help functions, which is db.help, help on db methods, replica, shell, sharding, show DBS names, show collections, show users, show profile, and you can also see a whole variety of the other ones also, like DB, how to find what you have inserted as documents. So all these things can be checked. Okay, fine. So we'll look at Mongo import later. So MongoDB is very much case sensitive. I've just copied all the notepad information into a Word document so that I can do some formatting here. So MongoDB is case sensitive, okay, and also type sensitive. Depending on the brackets or the syntax that you use, you need to do it very carefully. Okay, so there is a difference between an X, which is a 3, and an X which is like this. Okay, so there is a difference between these two, and the other thing to remember is you cannot have duplicate keys. Okay, so earlier I had used MFD and this one, right? So you can't use the same MFD key again and again. So let's say you have this one, you can't use the same thing to have welcome to this welcome again. So you can't assign the same key twice to 2 different values. And the key value pairs in documents are ordered. Okay, so whichever comes first. So you can't compare one with the other. If you have two documents with x1 and y is 2, this is not the the same as y2 and x3 x1. Okay, both are very, very distinct. You should not design your schema to depend on a certain ordering of fields. MongoDB may reorder them. Okay, we will see how those special cases can be addressed where field order is not really important. In fact, the default representation of a document does not even maintain ordering. Okay, so the drivers for other languages like Python, let's say, have a mechanism for specifying documents with ordering when necessary. A few tips about the document itself, and you already know what's a collection. It's a group of documents. Okay, that's why we call it as a collection. It's a group of documents. Okay, and collections have dynamic schema. Okay, so which means the documents within a single collection can have any different number of values, which could be of different formats, also of different data types. For example, if you have a welcome, so MFD and X can be stored in fact in the same document. Okay, one is a string, the other can be an integer, and so on. Let's do a small example. So now db dot, I have got something called things, okay, as a collection which I am creating. Earlier I had said you can create a collection as you reference it. That's an important point. So db dot things dot save, I'm going to save some values. Okay, so that is a is 1, b is 2, and c is 3. Okay, so now I have here this one. Okay, so after you enter this one, db.things.save, it has written this result. So there is a write function that happened. Okay, so one document has been inserted. Now if you want to find what is there inside this one, db.things.find with brackets there, it will give you a specific ID that I was telling earlier. That's called a object ID, which is very unique for this format, with the value of A, B, and C respectively. So you have a document in the collection. Let's say you want to insert another document. Okay, so the way you do it is db.things.save again, and here you have A3, B4, and C6, and D as say 200. Okay, now another result is also inserted. Now if I do db.things.find, it will show you two documents. Okay, so one is this one, the first one that you did, and the second one that you have. So you have two documents in the same collection called things in the database called db, and these have been assigned object IDs, which are very unique identifiers, and these are indexed. What is the meaning of index? You index few things so that you can search very, very easily. If you want to find the document where A is 1, see, in the second document you have A3, and the first document you have A1. If you want to find out the document where the value of A is 1, you can just type in A is 1. Okay, so it'll give you directly this document, and so it's very, very quick. It's already indexed, so you can see in this object you have A as 1. Okay, you can also add more documents like db.things.save. Let's do a different format now. Okay, A is 1, B is 1, and I have a fruit with an array. Okay, array should be always with square brackets, and you enclose it with an orange. An apple, a pear. Okay, you close it with a square bracket, and this one, a curly bracket. Okay, so if you enter this one, there's something missing in the brackets. Let me check. Okay, so I have reinserted or resaved this collection of things with save by giving some brackets there and then putting the array for fruits, which includes oranges and pears. Now if you look at db dot things dot find, you will see now that there are 3 different types of documents. You can also use something called db dot things dot find dot pretty. So it makes things a little bit prettier and easy to understand. So now here you have, after I typed in this pretty right there, with the ID, object ID, which is very unique, with this information of the document, and then this is the second document. Okay, so you have totally 3 documents beginning from 1, 2 and 3. Okay, so let's look at Mongo Chef. You can actually go to this website Mongo Chef and download from this 3t.io/Mongo Chef. Okay, once you're in there, then you can download the Mongo Chef, install it, and then try to connect it. Let me pull up Mongo Chef from my side here. Okay, so this is how it looks, and you have to connect it. I have already have a existing connection here, so if you want to quick connect there, right there, and if you want to look at the properties, just have a look at it. In the edit, you have to enter some name for your connection, and then the server is localhost. This is the port number for Mongo, and apart from that, you don't have to do anything else. The first step that you need to do after downloading Mongo Chef is to use this particular screen with localhost direct connection and then save it. Okay, so now I'm going to connect it. It's now connected. So if I click here, you can see that there are 2 databases, local and test. The same thing will be visible here. Show DBS. Okay, so local and test are visible right there, and inside the test database we have the things collection, which we created at the same time as we referred it. Now inside this we have the specific information where you have all this information that we entered there, and I double click on things. It will open up a new tab here, so we'll just close there, and then in things you can see that there are 3 documents. So this view is really good. You can also go to the tree view where you can see these 3 documents, or the table view in this fashion, or the JSON view. So you have A1, B1 and so on. The shell is right here in IntelliShell. So if you click on this, it will open a new tab where you can enter things that you want. So if I say db.things.find and click on either F5, which will execute the entire script, or F6, which will execute only this line, I can see information down there. So this is the latest Mongo version. It's connected to localhost 27017. That's the port number. Now if I click on this, which is execute statement at the cursor of line 2, then it is going to give me this information of the documents that are there. So you can also save the scripts that you write here by going to file and then save script, and then you can reopen the same script from there. You have all the typical crud operations, but they are termed in a different fashion here. So let me just put a table. Okay. Now let's look at relational in general, and then Mongo, and then SQL. So in relational, you have the CRUD operation, which is create, read, update, and delete. Okay. In SQL, let me just put it here and then that one there. In SQL, you have what is it called? Insert, and then you have read, select instead of read. Then you have an update, which remains the same, and then delete, which remains the same also. In Mongo, however, you have insert, and instead of select you have find, and so update will remain the same. Instead of delete you will have remove. So these are the CRUD operations comparison.
Just a quick info, guys. Intellipaat provides MongoDB training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session. Test your knowledge of MongoDB by answering this question. In which of the following is MongoDB written in? A. C++, B. Go, C. JavaScript, D. Python, E. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So you have I equals to 0, I less than 3, and I equals to I plus 1. You print hello. Mongo will give you the same thing. It will print 3 times. Okay. Now if you have the same equation or the function here, but instead of print hello, I wanted to print hello plus I. Okay, so I press F6 at the cursor level. Okay, now you can see it's printed 3 times. So I have I equals to this one, print hello plus I, so which will append this I there like 0, 1 and 2 for 3 times. So please remember the brackets here, the double brackets, and then inside hello there. So the keystrokes are of Emacs type of the editor. Control A for beginning of the query, Control E for the end of the thing. So now let's see what happens if we just type help. Right, so when you type help you get all these items, the same things that you get in fact for the terminal also. Okay, and if you type in help keys, let's see what it gives. Tab completion, command history as well, the command prompt. So start of the line, end of the line, Control K, delete at the end of the line. That is fine. Now if you want to try, we can do one more, which is for I equals 10 and I less than 10, I plus plus, print I. Okay, because it is the same, it hasn't given any information. Now let's say I'll just remove all these things there. If I say x equal to 1, y equal to ABC, z equals to, you can see how it gives you the information and the brackets when you're as you're typing in. Okay, so if I say z dot a, okay, now it will give me the value of 1 there. Okay, so if I now say z or z, okay, it remains the same. Now if I have w equals to a, and I want Z of W. Okay, it will still give you the 1. So there are different ways of representing 1 here. I just pressed F6 because at the line level it doesn't have any meaning. So that's why F5 will give you more meaning because it executes all these functions earlier. Okay, so dot notation is like a lookup of properties or methods or instance variables within an object. When you use the square bracket, it looks up data as dictionary with keys and values. How does MongoDB represent data? In fact, represents data using BSON. Represents data using BSON. Binary script object notification. It is like a nested dictionary. Okay. So we map the documents to objects in programming language to represent those key value associations. In JavaScript, the type of object is called JavaScript object. So you have your object equals to, with curly braces, you represent A is 1, B is 1, or let's say hello, and you can have a C which represents an array. So an array needs to be defined with a square bracket, and then you have your apples and pears. So I close this with a square bracket and this one. So this object can be a document. So MongoDB uses the binary representation as BSON. It is in fact a short form of binary JSON. That's the BSON actually. Okay. So if you go to bsonspec.org and look at elements or data types, you can see a number of them, beginning from a number integer, a number long, which would be a 64-bit integer value, a number long 1 plus number long 3. You can add those kind of long numbers. You can have a date. So to construct an object in JavaScript, you have to basically say object equal to this one, right? So it's important to understand that the binary JSON is a very flexible form of binary representation for JSON documents. Okay, so you know now how to insert documents. So if you are in DB, then you would say db.test, as a test is a collection, and then you insert something. Okay, collections are properties of database. Okay, so let's say now you have let me just clear all. So let me just clear it. The clear will be here. So I've cleared all the result tabs there. Now you want to add. Let's do another exercise for a different collection. Now let's say doc equals to, you have your name as, let's say, Smith, whose age is 30 and whose profession is as a hacker. Alright, now you want to do insert this into a new collection. So I'm going to create a new collection called people. As I'm referencing it, it will create. So when I insert this document there and you click on F5, okay, error, let me just check once here. Okay, so let's do error line 1. So I have to remove, there's an extra brace there, so I'm just removing it. And then I do an F5, which is executing all the script. It will create a document directly inside this collection called people, which it has just now created. Okay, so let's not do it in things. So you have name, age, and profession, right? That will remain the same. Startup logs, ID, fine. So you now have created. So people is a collection and insert is a method in database DB. So insert method puts a document. Now in order to query a collection, you have to say db.people. It will automatically give you that .find. Okay, so F6, it will show you the information that is there in that particular document. So underscore ID is a primary field with unique value. You can't change this underscore ID. Okay, it's a object ID is different from underscore ID. So object ID is a global identifier which is constructed and used as underscore ID. But underscore ID is a primary field which cannot be changed. Right? You go to click on test, right click that and then click on refresh all. It will show you the new collection that you have added. So that's people with its own underscore and then things. So you have now got two collections. Two collections inside this test DB. You can also change the DB by saying use local and then create new kinds of collections. So in people collections, you have got one single document. In things collections, you have got three different types of documents. So we were talking earlier about why is there a need to create more than one collection, because in one collection you can have different types of documents and data types and merge them together, including arrays, dictionaries, and so on. One of the reasons that I had stated was keeping different kinds of documents in the same collection can be difficult for developers and administrators. Devs need to make sure that each query is only returning documents of a particular type, okay, or that the application code performs a query that can handle documents of different types. So it's difficult to take out documents containing some other information. So it's to make it more simple, you have more collections. The other reason is that it is much faster to get a list of collections than to extract a list of the types in a collection. So let's say if you had a type which is, let me write it here, you had a type field, all right, in each document, okay, that specifies whether a person is slim or obese. Okay, it would be much slower to find these two values in a single collection than to have two separate collections and query the right kind of collection. That's the second reason. The third reason is that grouping documents of the same kind together in the same collection allows for data locality. Okay, so you can get several different kinds of information about a person from a collection containing only that data that is more likely to have a less or fewer disk seeks, okay, and more data locality and therefore more speed, right? So this is also one of the other reasons that we have multiple collections. The other final reason is that you begin to put some structure on your documents when you are creating indexes. For the sake of index also, you can have multiple collections. Okay, when you can have multiple indexes too, but this is more true when you have a unique index. So this index is defined per collection. So index per collection. So by putting only those documents of a single type into a particular collection or in the same collection, we can index our collections more efficiently. Okay, so there are really good reasons for grouping related types of documents together and collections together, even though Mongo does not really enforce that kind of a rule. A few other things to remember about collection. This is not a valid collection name. Okay, collection names they should not contain characters like \0 or a null character, because this is not proper for a collection name. We should also not start a collection with system, okay, as prefix. Okay, this is reserved for internal collections only. Internal collections only, because you may have system.users, which is actually a collection that contains all the information of the users who are accessing the database or the particular kinds of collections. In the earlier one also, you can have blog.authors, you can have blog.posts. There could be absolutely no relationship between these two, but you can form sub collections also. Their usage is very highly recommended by Mongo community. This IntelliShell is also it works as a fully featured JavaScript interpreter, which is capable of running arbitrary JavaScript programs. So if you do any basic math here, for example x, and then you do an x by 5, so and then run this code here, it will give you 40, and let's run this code. So I put F5 and it has given 200 here. So it's actually given 3 different results for me. So text, and text is again 200, and the final text is 40. So x by 5 is 40. Okay, so if you do only this one, f by 6, it will give you the same result here. Okay, so it works as a JavaScript interpreter. You can also do many other functions like factorial, like sign data, cost data, math, and so on, which are very useful functions. The real beauty lies in the MongoDB client, which is actually a standalone one. So on startup, earlier you have seen DB and then test like this, isn't it? DB, and then you have seen the test collection. So now what exactly happens is that the shell connects to the test database. Sorry, the test is a database on a MongoDB server and assigns this database connection to the global DB variable. And this DB variable is the primary access point to your MongoDB server through the shell. This shell itself will contain some add-ons, and these add-ons do not provide any extra functionality, but they're nice to work at. For instance, one of the most important operations is selecting which database to use. So if you want to change the database, you would say here, in this case, you have 2 databases, local and test, right? So if you say use local, then your the next operations will be done inside this local database. Okay, all kinds of collections can be accessed by entering db dot and then the collection name. This returns the COL collection in this particular database, and that is local. Okay, if you look at the data types that are there in MongoDB, there are 6 basic data types that actually belong to the JSON family. So documents in MongoDB are more like JSON, the JavaScript object notification, and very similar to objects in JavaScript. So the 6 data types that JSON provides is null, boolean, numeric, string, array, and object. And null can be used to represent both a null value as well as a non-existent field. So for example, you may write it in this fashion, which is a value of x can be null. Okay, and then you have a boolean, which is a true or false, and the shell defaults to floating numbers, so therefore these numbers look normal in the shell. You may write x assigned to 3.14, x to 3. String is again any string of UTF-8 characters that can be represented using the string type. Dates are from Mongo. They are stored as milliseconds, and the time zone is not shared, is not stored actually. So the way you write the date should always be like this, which is x and the new date. You do not write just date but the new date, and that's the idea. Regex is the regular expression that queries can use regular expressions using the syntax of the same. Array, it comes again from JavaScript. It sets or a list of values. Embedded document within a document. So you can have documents that contain an entire set of documents embedded as values in the as a parent-child relationship. Object ID is a 12-byte ID for your documents, and your binary data is a string of arbitrary bytes. It can be manipulated from the shell also, and then the code, which is the queries and documents, can also contain some arbitrary JavaScript code. These are few types that are mostly used internally, and remember to have the date always as new date rather than just the date like I have written here. So that new constructor is absolutely important. Arrays, we have seen a few earlier. Embedded documents. So here when you have an embedded document, your document becomes the value, okay, for a key. So in this case it's called the embedded document. They used to organize data in more than a flat structure of key value pairs. So embedded documents will look something in this fashion, where you have info, which I have created as a document, equals to so on, with name as John Doe, address, street, and this one. So the address here is itself a document that is embedded in this particular document. Okay, so the address itself has got these braces, curly braces, with 123 Park Street, any town in New York, and that's there within the info. So there's one document embedded here. So if you run F5, it will tell you that first of all it's a document, and that it represents this particular format. So underscore ID and object IDs, these are again two different kinds of data types that are there in Mongo. Every document that is stored in Mongo must have an underscore ID. This ID key can be of any type, but it defaults to an object ID. So in a single collection, every document must have a unique value for underscore ID. So this basically makes sure that every document in a collection can be uniquely identified. So if you look at this things collection where you have 3 documents, each ID has got a different value, and this actually represents these documents, these 3 documents individually and uniquely. And neither collection could contain more than one document with the same ID. It has to be completely different. And then you have this object ID, that's the default type for underscore ID. It is a very unique way to recognize globally across different machines, and it is very different as opposed to auto incrementing primary key, which is quite difficult and time consuming. So it rests on the fact that MongoDB is designed to be a distributed database. So it was important to generate such unique identifiers in a distributed environment. So object IDs, they use 12 bytes of storage, which effectively gives a string representation that is 24 hexadecimal digits, 2 digits for each type. So the first 4 are for the timestamp, the next 3 are for the machine, which is a unique machine from where this ID was created. This is the process ID for the next 2, and the last 3 are incremental values. So look at this hexa decimal digits. This is actually a 24 bytes. This is 24 bytes. This is also 24 bytes. The last 3 are incremental, 2e3 and 2e4. For array it is slightly varying. So in this format, the 12 bytes of storage are actually generated. Even though an object ID is represented as a giant hexadecimal string, the string actually is twice as long as the data being stored. So you have an insert, and you also have a remove. If you use remove, then it deletes all the documents in a particular collection. So let's say you want to see what documents are there in this people collection, and you want to delete it, right? So we go to the IntelliShell, and then we would say, let's clear this off first, and then db dot people. Okay, it's already giving us there. Dot remove. Okay, and then close it and then run it with F6. Okay, so the error says error remove needs a query. Okay, so you have to put two braces here inside, which is actually a blank there, and then when you run it from here, then you would see that the document is removed. Okay, now if I try to see it, there is no document. So db.people.remove will remove all the documents in this people collection. If it gives the error no query found, or you need to provide a query, then you have to give the color braces there. But also remember that this doesn't actually remove the collection, so the collection stays as it is, and any metadata information about this collection will still exist. The remove function optionally takes a query document as a parameter. Now when that kind of a query is given, then only those documents which match such criteria which is given here inside the query only will be removed. Once the data is removed, okay, so there's nothing here. Once it is removed, it is gone forever. There is no way to remove or cancel the remove or recover the deleted documents. Once you do it, it is gone. Now when you use something like this, db.people .drop, in this case the entire collection is dropped. Okay, which is basically, and all its metadata information is definitely removed. Okay, so this is very important. Now it is true, and therefore if you go to test and refresh all, you will see only things. There is no people collection in this. Let's do an example in insert document and also update a document. So an insert document will have the format like db.collection.com .collection .insert, sorry, not .com, insert, and then you have your document name. Okay, so this is your collection name, whichever you have here, and then you insert that particular document. Let's clear this up and let me write a new one. So a db dot, so I'll use some post as a collection in this and I would say insert now I'm going to insert multiple documents in this. So the way we want to create it is insert and with square brackets okay. So let's try a new one for using the insert and the update there. Okay, so let's do a new collection called post. I've just included that one. Okay, and let's insert. Let's say the title that we have currently is MongoDB and description. Mongo is NoSQL DB, a comma by Intellipaat. Okay, curly braces, comma. Let's do another document here continuously, which is, so this is going to be title, which is NoSQL DB, description. NoSQL is schemaless, again by Intellipaat. Okay, so let's say you got some likes for this, and maybe you got some comments also, but let's see. So you have some comments. user from Frank. His message is very interested. Okay, and now let's close it. Okay, so it'll identify where which bracket is getting closed by this one. So you have this mentioned, and if you put it there, it'll show you all those things. Okay, so now let's do an F5. Okay, so it is inserted. Let's see what is there in this db.post dot find. Let me close this. I'm doing only a F6. So here I've got two documents. Okay, one is this with the MongoDB overview, and then the second one is NoSQL database. Now we have inserted two documents in this collection called test. So Control R will show you the post. If I want to add or update this particular title, then you can use the update functionality. Okay, the way you do it is, so let me just go to the next few lines. So you do a db.post.update, and then you use the title.
Just a quick info, guys. Test your knowledge of MongoDB by answering this question. Which of the following represent column in MongoDB? A. Document. B. Database. C. Collection. D. Field. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Which title you want to change, and that is this one right there. MongoDB overview. Whether you use single quotes or double quotes, it's all the same. So you want to change this, close the brackets. But in order to help Mongo do that, you need to set, okay, and set this title to what do you want it to be. So now I want it to be MongoDB for developers. So I close this. This is done, and another bracket there to close it. And in addition to this, what you have to mention is if you want it to be done in multiple places, let's say there are some more documents, okay, which have the same title, and you want to change everywhere where the document title is MongoDB overview to MongoDB for developers, you use something called multi documents to be set as true, and then you close it. But since we don't have it right now, we can as well close it with this one there. Okay, now let's run the this particular thing by saying F6. So right result matched 1, yeah, upserted 0, and modified is 1. We'll look at upserted a little later. Now if you do the same thing there, what you have done just now for db find, and do an F6, you will see that title is changed from MongoDB overview, this one, to MongoDB for developers. Okay, so if you want to do a multi-document change or update, you can use multi as true parameter there. We have now seen the installation of MongoDB on Windows, and I've also explained on how to do it on Linux and also the Mac systems.
Data types, MongoDB data types. So here there are mainly 16 data types in the Mongo database: double, string, object, array, binary or binary data, undefined, object ID, boolean, date, null, regular expression, JavaScript, symbol, JavaScript with scope, integer, timestamp, min and max key. So there are totally 16 data types in the Mongo database that where we required. So remembering all these things would be really tough. Okay, practicing everything is a must. Okay, so the very first one, which I would like to just show you, major things. Okay, let us try to work on this. So here, the first one is double. Okay, double refers to floating values. Okay, now first let me just explain you double and string. Okay, array and object. Double, string, object and array. Double, string, object and array. So now the first one, let us work with the double. Double deals with the floating values. What do you mean by floating values? Floating values are none other than 123.45, 100.24. These are all values, fractional elements or decimals. Yes. Okay. So how to represent this part? Take a look at this one. Okay. Here, you can always declare a variable in the command prompt with the help of a keyword called var. See, this var is nothing but a keyword in the JavaScript. Okay, var is nothing but a keyword in the JavaScript in order to mention, in order to declare a variable. Okay, this is nothing but, this is how that you will define a variable or declare a variable. So I wanted to declare a variable double. Okay, double data type, double dt is equal to 123.45. That's it. And now I wanted to print double dt, double dt. Okay, now in the same way, what do you mean by a string? So again, when it comes to the string, all the textual data can be considered as a string. Okay, understand? A textual data which can be considered as a string. So whatever that you are writing inside is nothing but most of the text you can clearly understand. Okay, so string, usually you will have it the encoded format of UTF-8. Okay, so this is the most considered character set when you are working with any database. UTF-8. Okay, see, even here when I'm going to save this one, for example, if I'm going to save this one as, can you see, these are the encoding formats. These are the encoding formats: ANSI, Unicode, Unicode, Big Endian, and UTF-8 are the different types of encoding formats. Okay, so required much more than this one to understand this one, to understand the subject. Okay, UTF-8 is a one sort of encoding format. Okay, when we are saving the files, even when you are saving the data in the database, okay, even there will be a certain character set. So the default character set, okay, that should be UTF-8 valid. So this is what we have, the strings. Okay, how it is following the UTF-8 method validation. Okay, now when it comes to the object, basically an object could be considered as an embedded document. Guys, it was already clear, like when we have worked with inventory. Can you see there is an embedded document over here? What is that embedded document here? There is another set of key values inside a document, a document inside a document. Okay, a document inside a document. Take a look at this one. So here, this itself one key value pair, inside which you can see a lot of key value pairs, right? So can you understand, this is a document which are enclosed. So this is a field, this is a field, and this is a field, and this is the value, and this is the value, and this is the value. This document is there inside this document. Okay, a document inside a document is generally called as an embedded document. Okay, and the embedded document will not have an object ID. Can we have an object ID for an embedded document? This is what I'm going to ask the question. So the answer is there is no object ID for an embedded document. Actually, we can call this one as an embedded document itself, but talking is the document inside an embedded document will never have an object ID. So never directly talk like this. Embedded documents don't ever have the object ID. No, it's wrong. Okay. So even when you are writing an examination, please don't refer to something like that. Embedded documents also will have the object IDs. But what I'm talking about, an embedded document which contains a document inside. Okay. So next one is an array. So how to define an array? How to understand an array? Array, when it comes to this, let me show you. You can see I have provided an array of elements in the in stock. In stock, I've seen, you can see here clearly. But when it comes to the in stock inside here, this is an array. So now let me show you this part, mark. Okay, let me show you this. So here you can observe that something like this. Okay, not sure that. Okay, fine. Now guys, you observe that here this is an array element. This is an array element. Okay, inside the square braces. Okay, array element 1 comma array element 2. An element is again a document. Okay, an element is again a document. So you can clearly understand that this is an object and this is an array. Okay, this is an array and this is an object, and we understand the what is string and we understand the what is double. Okay, so now what I wanted to explain you is the next one, the next set, which is nothing but the binary data. Binary data, undefined object ID, and Boolean. Okay, so now let me just talk about this binary data. So here I would like to just create a collection, and I would like to just insert something over here. I'm already inside the salary DB dot. My okay, I wanted to create a. I have already a hike collection, right? So DB dot hike dot. I wanted to insert something. Okay. Inside this, I will be inserting just a greeting. Greet. Hello. Okay, I've greeted, and now hello, or otherwise say hello. We can. How are you? Now I wanted to say the value binary. Okay, value binary is a one attribute that you can always use to provide. So here it stores as a binary data in the background. So value binary has to be referred as A over here, and I'm going to close this one down. Okay, it was causing some reference error. Now let me just add some object ID. Okay, now let me add up something. Checked off. Exactly, the A is not defined. Okay, I'm also like providing the valid object. Okay, if not even, it would be always, you can even give something like this. Here you can make the underscore ID. First, let me just provide it as like any one object ID, whatever it might be. I'm just creating an, I'm just calling a method object ID. And I would like to provide one more key, which is greet. Okay.
Just a quick info, guys. Intellipaat provides MongoDB training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Let me just find out, first of all, find dot ready. So we can see that an object ID which was created, okay, based on our own, you know, creation of the object. Okay, that's why you can see the pretty was not defining in a different way. You can clearly see this. Without pretty, with pretty, it was unable to carry the a kind of indentation with that. Okay, so that is clearly visible over here. And now what I would like to show here, let me just try the same thing. Okay, but here what I wanted to consider is the value binary, which is very specific. How to just mention this particular data, whatever that I have just provided as a value, that will comes under some sort of binary format. Okay, so we already know that there is something called the bson. Okay, so the bson is something which is different, but of course it is none other than binary JSON. Okay, so here binary data that you can always convert with the help of one simple thing is nothing but a value binary. That is none other than a parameter which we are providing here. Okay, so in the Mongo database, when we are converting these binary values, we always have the respective subtypes. So it can store this particular binary data accordingly. And definitely we require to use a respective binary data representation when we are using it. Okay, so whenever we are using, what do you say, like whenever we wanted to convert the entire, whether it might be respective, whether you are going to use you know a string or number type, okay, or any other thing, we should definitely going data that you wanted to convert into the binary format. Okay, so here the binary data representation is clearly provided here in the Mongo database. Let me just show you. Value binary data. So bson types. So you can see double, string, object, array, and binary data. Okay, so here you can even either use a numbers also according to the specification, what exactly that you wanted to make it in the binary serialization format. This is a serialization. We should not change the serialization again, and the alias which was clearly provided. Okay, out and which, like you can see, this is one. There are two things which were deprecated. Okay, anyhow, this was not represented in your slide, and also the undefined was also the another one which was deprecated over here, and symbol was deprecated. Okay, and also JavaScript code with scope is deprecated. Okay, and yeah, decimal 128 is something which is new in the version 3.4. Okay, which was since from the version 3.4, decimal 1 to 8 is a or more stuff. So minimum key value and the maximum key values are all these things, just to make you understand that this is how the binary serialization data, how the bson data types are being used or supported by the Mongo database. So now let us come back to our example. Okay, now here I have just provided something like this, and okay, now I would like to provide uh, one more without this object id, the same greet. I will be able to enter this or not? Same greet, same thing, everything is same, there is no difference. Okay, let us try that one also. Insert it. So now let us see the pretty. It has provided a different and unique thing which is considered as an object id. Okay, and now let us try passing that bson, okay, which is required to be a binary format. Okay, so basically the binary format which we are referring should be referred with a value binary. Okay, value binary is something of an attribute which we are just providing it inside. Okay, but the reference is the one which you are just providing should be the kind of data which you have provided has to be saved in terms of the binary data. Okay, so here this is what we are hitting up an error. Okay, here when we have just given this one, there was an exception which was causing by the reference error, which is nothing but a. Okay, so why? Because we are not so here you can see the value binary which is required to be converted into a respective considered data. It is not respectively to be converted into the value of the binary. Okay, so I will be showing you through using the JavaScript way how exactly that we can convert this one into the binary data, or how exactly it is going to be stored as a binary data which could not be shown. Okay, when someone, I mean the value of a binary can be stored, how exactly it is being stored and all. Okay, so the next one I will just cross verify that one, and I will just come up with one more notation, okay, which I did not find out properly. Okay, and coming to the next one, which is undefined. We have seen that undefined was already deprecated. Next one is a object ID. So here, whenever that I'm going to use an object ID, see, basically what happens when you are going to when you don't define anything else. Okay, when you don't want it to define anything else, then you can provide undefined. Basically this is what, still you can use it, not an issue. For example, if I am going to talk, for example, I don't know what to define here. Undefined. See, now you can see pretty. Can you see undefined? Basically you cannot provide a value of undefined something like this. Agree or not? Basically you can never provide any value other than this undefined. See, I will show you. Apart from undefined, if I'm going to say undefined, it is giving an error. There is a reference error. See, basically it will give a whatever the value it does not able to understand over here, it will be saying that it is undefined. Okay, so that is what happened over here. Okay, so next one, coming to the object ID. So object ID is by default it will be created. So an object ID is nothing but an hexadecimal format. Okay, an object ID which you can see over here. This is nothing but a unique key which is going to be useful in order to index the document. Okay, so the data which is stored in this particular ID is in the format of the hexadecimal format. Okay, so which we already aware of this one. Okay, now when it comes to the Boolean, we know that, you know, how do we insert the data. Okay, so when it comes to the part like db dot hike dot insert, whether the hike is accepted or not. For example, how can we provide basically hike status, given or not given, true or false. Okay, so I want to just give it false, insert it, you can see status false. Okay, true or false can be mentioned, something like that. Okay, and coming to the date, so whenever we are working with the date, you can always use a variable, a date. D is equal to date object will be referred something like this. It will provide us always, whenever you wanted to, you know, print D, you can see it is providing us current date and time. Okay, it is providing us current date and time. For example, if I'm going to create this one as an object, a new refers to an object actually. So D1 is equal to new date. So now this D1 is none other than a date object, which is going to show you in an ISO format. Okay, fine. And I always use this. I can always use this in order to insert into this again. DB dot hike again. I'm sorry. Hike dot DB dot hike. I wanted to insert D is D, otherwise date D, and that's it. Or we can provide even the other one also, D1, ISO date is D1. Right. Yeah, ISO is nothing but in organization for standardization of the date and time. Okay, one type of format. Okay, so here when I wanted to mention a null value, null is neither 0 or not a value. Okay, null is nothing. So variable x is equal to null, for example, and when you print x, it is nothing but a null, and I wanted to insert this particular variable x. So db dot hike. Okay, yeah, ISO date format. Yes. No, basically when you take the Linux platforms or Ubuntu Unix flavors, you will see the ISO date formats, which is together, you know, a date and a time. You can see this is a one sort of format, date, time, and zone. So likewise, it will be, everything would be represented over there. So db dot hike dot what else? What we are doing here? Okay, null value insertion. Okay, insert. Now you can see a new value. I'm going to show you a new value. It's none other than x. So now let us see the results. You can see the new value was null. Okay, so likewise you can just implement this. Okay, now we will go ahead with the regular expression. When it comes to the regular expression, it's all about I mean to say, yeah, if we want to keep talking about this, there will be a lot of thing into the regular expression, but still keeping it in very short, I would like to just open up and show you one JavaScript program for you, okay, in my Visual Studio Code. But don't get,
deviated. This is all with my interest I am showing you. There is no point in showing the JavaScript code right now, but to make you understand how the regular expressions are going to work. Okay. See, let me just show you this one. See, take a look at this one. It's all about matching something. Okay. Here I have taken a see. There was a word JavaScript. Word is nothing but full stack course. Something is in demand. Something blah 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 is there. Instead of full stack, okay, let me say this is a JavaScript. Script. Okay. So this JavaScript is there here also. Okay, very good. Okay, so word means this variable name dot matching. Match is a function inside which that you are passing in another variable called pattern. What is this pattern? This pattern is the regular expression. So what is this pattern? Forward slash power symbol.
Just a quick info, guys. Test your knowledge of MongoDB by answering this question. In which of the following is MongoDB written in? A. C++, B. Go, C. JavaScript, D. Python, E. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
From capital A to capital Z or small a to small z. Dollar means whatever that might be after that. Okay, means whatever the text might be later. I doesn't bother about it. Okay, so here this is how it has to identify. So this has not identified anything else. One second, let me change this pattern. Still providing us. Yeah, here it is. Okay, let me just go with this one. You can see here, I wanted to word is something like this. Dot replace. What exactly that I wanted to replace is, see here, instead of JavaScript, I'm just making full stack. Okay, where that I see full stack, that should be replaced with this one. GI reference means global. Globally, wherever I see full stack or this full stack, it has to be replaced with the UI. That is what my main concern. So here this should be UI course, and again there was one more full stack. It is that is again here full stack. So now let me execute this one, only this one. I don't want this part here. Okay, so if you can take a look at this one, I'm executing. You can see the full stack was updated with UI. Means this is what the regular expression replaces a function within the regular expression, okay, represents forward slash either this word or this word globally in the entire sentence, irrespective of the case. I represents the case insensitivity, okay, and wherever that you identify that word, you have to replace with the UI, okay. It's a JavaScript. Actually, you can identify the regular expression concept in every programming language, Swati. Okay, so likewise, whenever you mention percentile, there is a one meaning to it. I mean to say, whatever that might come at the place of percentile. Percentile means one word, okay. Dollar symbol means exact match, okay. Star representation means zero or many, okay. Question mark symbol represents zero or one time, okay. Something similar to that one. Understand? Exact match means you need to use a power symbol and also the dollar symbol, okay. And period represents any character, plus represents one character, okay. Likewise, there is certain rules, okay. In the same way, even it can store the regular expressions in the Mongo database also. So now let me give you the same example over here. So when it comes to the regular expression, I would like to first create an object of this. Reg exp equal to new reg exp of whatever that you want. I want everything like this. Test. That's it. So whenever I say regex, it's none other than this one. So now what I wanted to do is I wanted to insert the same thing. Okay. So db dot bin dot insert into name regular checking comma and status gxp. That's it. Now db dot bin dot bin dot pretty. Can you see this regular expressions, how exactly that it was represented as it is? So that can be extracted by any programmer, okay. They can use this one in their front end wherever they want based on the set rules and all. This is one more fantastic options. We have next one is a JavaScript, okay, keeping a function itself. So let us try to learn one function, okay, some basic function. Functions, okay, you can see a very basic thing. Writing a function. You can see like how a function could be created. I can always have a variable, okay. variable fun equal to 1 equal to, okay, I can keep my entire function into one goal. I mean to say, like a function of something inside console.log of hello. Okay, see, the function name was not at all defined over here. Basically, for example, if you just take a remove, basically we have to keep a function something like this. See, I have a function called print. Okay, so where I can print something whenever, if I'm going to call this print function, okay, see, you can observe that I have printed hello. Did you all understand? I have created a function in the JavaScript function like a printing. Okay, see, what I wanted to do is I wanted to copy and keep everything into the insert statement. Take a look at this one. So insert, I wanted to name new function and stuff status. I would like to just put it code. Inside this code, I like to keep everything inside this. It's gone bad, I think. Actually, I forgot about the enters and all are there, right? That has become a problem. But until still, I have inserted some code now. You can check it out. See, my function has some code inside. If you want me to reinsert again, see, I would like to just new function 1, and inside which you wanted to add some more things here. Console total log off. So, yeah, some syntax error. Why? Because some wait. It is not allowing as it is in the JavaScript. So some sort of code is allowed, but not all the stuff. A variable declaration is quite enough. Okay, variable x. You can close this down. This is quite enough actually. More than this, it will not even, I think, allow you. So now this is insert. Now you can see the variable x inserted. Means you can insert a code also. Okay, JavaScript code inside the respective, unless and until the syntax was gone ahead. Okay, we will go for the next one then. So what is the next one we are waiting for? Symbol. Okay, you can provide different symbols actually here. See, basically symbols, how exactly that you can resemble. there will be any symbol with a combination of characters, or when you wanted to input some sort of symbols also, okay, as not like a regular string context, where you can use this, where you can even consider trying this kind of data type also. So this is pretty simple, where here I would like to show you search equal to, I wanted to keep it HA hash dollar $2 hash $4 such is something like this, and this is how that I would like to just insert even same. See, the same thing, code is equal to sh. That's it. Oh God, sorry. Code is equal to sh. So you can clearly see the symbols where we have provided over here. Okay. Likewise, we have the JavaScript with the scope also. So this scope is not required to explain you again very specifically. Why? Because this is nothing but a context that you wanted to provide. Okay, whether it is an object or an array, what kind of scope that you can implement this particular code with respect to the with respect to that particular document. It is allowed in the Mongo database to use this particular JavaScript data with the scope. So this is quite fine. And integer, so integer as it is, this is not something superficial to understand. First point, you can use some y is equal to 180. Okay, and you can always try inserting this y, and you can see the inserted code. Okay, this is an integer, means the data variable, how exactly that you are using inside when you are creating a new insertional statements of the Mongo database, and how exactly that you are coming up with the respective content, okay, which was inserted inside the database. Okay. For example, the timestamp, we have the last and foremost thing, and we have one more thing, of course, minimum and maximum keys. Before I explain you this part, timestamp, it's a basically 64-bit value data type. Remember that this is a 64-bit value data type. So where exactly it is going to see, we have to create an object for the instance for this one, for timestamp. So I'm going to explain you the same thing. So var ts is equal to new timestamp. I've created ts is equal to, okay, it is letting me not show you. Actually, it has to show us based on the provided value. Basically, when you take it here, you can clearly see that you have got the 0,0 values. Okay, so now what exactly that I can do, I'm going to pass out this particular variable accordingly inside the context. So here you can see that I'm going to insert the same thing. Instead of code, I'm going to make the time representation rather ts, and that's it. Now let me check it. Can you see the timestamp? So 16/06/58/0099 is nothing but the timestamp which is being provided. Okay, so for the whatever the object or instance that we have created. For example, if I'm going to use the same thing again to insert again, insert, No, not this one, right? STS. So you can see the change of the time was clearly observed over here. Okay. As it is a 64-bit value, there is a conversion formula, okay, where you can see that how exactly that it is being represented from this line. Okay, you can see that's why. What exactly the differentiation from here to here is nothing but a 1 minute of time that you can observe. Okay, see, order. Actually, when it comes to this one, this is a timestamp that we can clearly understand. Whereas this is nothing but the order of execution. So number 1 represents the first order of execution actually. Okay. So when it comes to the min max, so it will identify the minimum key and the maximum key. The minimum key compares the value of the lowest boolean element. The max key compares the value against the highest boolean element. Okay. So as a part of it, let me just try inserting an element, and also I would like to show you a live demonstration of this. Here, what is the DB users? Show collections. We have these collections. Let me do one thing. DB dot keys dot insert of inside which I would like to provide some elements. Okay, an array of elements within which I can provide comma and I would like to enter a Boolean value also. Null value also. And min key max key. Totally 7 inserted. Now I wanted to query this. Okay. See, if you can understand, I have inserted an integer, floating value, string, Boolean value, null value, and a minimum key value on maximum key or something like that. Now db dot keys keys dot find. This will give you some data, right, like this. So here you don't understand when you haven't sorted anything else. For example, if I wanted to sort according to the A wise. Okay, A is a key, and 10, 12.22, Bhanu, true. Keys is the collection name, Narendra. Okay, true, null, all these things have become a values. Okay, so now take a look at this one. I wanted to dot. For the first time that I'm just showing you how to sort the data. Sort by what? Sort by A. Okay, A colon confirm 1. So now you see this. Whenever you have sorted by A, you can see the order. Minimum key is the first one, maximum key is the last one. So here, what exactly we are trying to understand? The minimum key is comparing the value of the lowest bson element, which is nothing but A of A colon minimum key, A colon max key. Max key, these are the data types. That's why we have used those data types in while we are inserting something inside the collections. Okay, finally we are landed on the Mongo database relationships. How to understand the Mongo database relationships? Hmm? What is this for the people who is completely new to this database and the stuff? Let me explain you what is the concept of this one to many or many to one or something like that. Guys, here Amazon users, for example. Okay, username and password, address. So an Amazon user might contain number of addresses. So address 1, address 2, address 3. Agree or not? So here we should have a separate table for the addresses. Okay, where you cannot maintain number of addresses in the same table as a different column names. Okay, where you can't keep it in a different column names. You can fulfill something like this. Okay, address 1, address 2, address 3. This is one, but you have different addresses. Okay, each and every user contains one user profile. That is one to one. Every user might contain number of different addresses. One to many. Many books segregated to one particular category. Many to one. The relationships in between the different tables at a very layman style that I'm talking about. Okay, now as a sample, one to many relationship tables, images. See, here you can take a look at this one. Customer table, okay. Customer might order number of orders. Order 1, order 2, order 3. means customer table to orders table, it is a one-to-many. Okay, so likewise many-to-one relationship. Many-to-one. So when it comes to the many-to-one relationship again, so it's not so easy. Many-to-many you can find out, but many-to-one you will find rare. But as I told you earlier, different types of books coming to the, considered under the same category can be approached as a many-to-one. So many-to-many represents every table might be depending upon with a lot of primary keys or foreign keys interlinked. Each and every table is dependent upon the other table relationship. There is a relationship between the tables each other. Okay.
Just a quick info, guys. Intellipaat provides MongoDB training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session. Test your knowledge of MongoDB by answering this question. Which of the following represent column in MongoDB? A. Document. B. Database. C. Collection. D. Field. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
But how to represent that one in the Mongo database? There is a two varieties. One is embedded and referenced. Now let us see very briefly what is this embedded and what is the reference. Okay. Take a look at this one. Let us consider the case of storing the addresses for the users. Okay. When you are taking the case of storing the addresses for the users, you can clearly understand this is a short example of name and a contact number and the date of birth. Okay, where each and every one user can have the multiple addresses, so which is nothing but one-to-many relationship. Okay, so in the embedded, this is the address. Actually, this is the name and contact number and the date of birth, and this is the address. But how this particular address document is going to be embedded in this particular user document? This is user document, this is address document. Now you see the embedded document was prepared list of documents inside an array of elements assigned to the field called address in the user document. I can show you an example also. One second. It's a very complicated one. See, this is a very biggest one. You can see how much big it is. Inside this there is a key value pair, and inside one key there is a very big value. The complication of how exactly a JSON file looks like, JSON document, this will give us some prompt feeling about how big is this and all, but ultimately this is very easy to work on. Even JSON formatter, right? I will show you. There will be viewers, online free viewers, where you can see okay, okay, this is one of the best. Actually, I think this is the only one best thing that you can validate. See, it's all about now where exactly that you want to close this. See, snippet. If you are going to enlarge the snippet, this is the one. And inside again, notes. Inside again. This is a sample JSON script which has been prepared for a chatbot. Okay, and I have written a code in the JavaScript in order to extract the information out of it. See, this is the one, right? I don't know like whether the output was still there. No, yeah, it is not there here. No. Okay, so now let us try to compare. See, you can reference the another document by using the respective item key when it comes to the referencing point. Yeah, so this is the address. Object ID refers to this particular ID. See, I_ID is equal to object ID. Likewise, you might be storing these addresses in some other documents, and those documents relevant object IDs are going to be stored over here, right? So here you can reference even some other documents in the existing document. While doing this referencing technique, this will help with the information consistency, and also it will update the efficiency. Okay, if any update to any document is happened, then you don't require to update to all the collection. Why? Because if there is any update in the respective address was changed, you don't require to change it here, right? Right or wrong? Whereas when you go for the embedded, when you embed something like this, whenever there is an address change, it has to be changed for all the respective addresses in all the respective documents also. Agree or not? Here, that is the one of the advantage with the referencing concept. Whereas coming to the embedding concept, you can always embed a document in another document by defining an attribute to a document. Okay, and embedding can hide the information consistency, and will update the efficiency across the documents. Here, you take a look at this line. If an update to any document is assured, all the collection embedding the same document have to be updated to ensure all the redundant copies of the document are identical. As I told you, likewise, how many, see this RAM, so and so called name RAM is there in whatever the collection it was, wherever the address is being changed over here, that should be respectively updated in even all other documents also as well. Why? Because it is not just like a object reference, it is going and happen here. Here, it is just an object reference. Any address information what was being changed, you do not require to update it manually here. So when I'm talking about the different types of statements, we have just clearly covered this insert and update. But let me show you how do we drop a collection. How do we drop a collection? See, show collections. I have 3 collections in my hand. I wanted to delete collection called bin db dot bin dot drop. That's it. True. Now, if you can see this show collections is not going to show you the bin. Understand this? For example, I want nothing but delete. That's it. Okay. For example, in which database that I'm in? Users database. Okay. I wanted to drop this database. db dot drop database. Done. Dropped. And if you can see show DBs, you cannot see the users database. Actually, here there is something. When it comes to the collection, you see that, let me show you by using one test database. See, I'm using test. Okay, db dot, okay, show collections. Let me show you the collections. This is the collections. If I wanted to delete something, db dot r db dot rasa test dot. See, you have this many number of implementations that you can perform on this. Delete one, delete many also is there. Okay, but this delete many will work only for the documents, not for the collections. You need to understand that. Okay, delete one document or delete many documents based on the logic you are providing inside, but that is not for the collection purpose. So when it comes to the querying, there are many things that we can perform when it comes to the querying part. We have a different ways of performing the operations of data, which is limited sometimes. Okay, how we are going to query the documents. Okay, reading all the data, or getting the data very, very much specifically. Likewise, we can always make up different ways of generating or getting that particular data out of this particular JavaScript. Okay, when you wanted to read all the documents, I don't require to specifically mention you that dot find is the main thing, like perspective that we can always go ahead. Show DBS. Let me see which is best data. Get something. Use. See, for example, I wanted to see only the list of courses. So how to represent that one? Only list of courses. Course dot find of. In this find, I have to mention where the C name, course name is Java. I wanted to just filter the data wherever the course name is Java. That's it. This is nothing but select star from course where course name is equal to Java. Okay, and if at all, this is a conditional statement. I'm not trying to filter only the course name. Okay, I wanted to implement what exactly that I wanted to see. That's it. Okay, for example, I wanted to say course name in multiple names are there in my mind. It is not a one single item. So there I'm going to use operators. Okay, which operator that I'm going to see? Which operator? In operator. In operator, using in operator, I'm going to add Java. I'm going to close this. Along with Java, what I can add? Oracle. See, Oracle is there. Now you can see. MongoDB is also there. See, yeah, array of values I'm providing here. Okay. I've ignored completely everything apart from CNAME and the underscore ID I have made it as 0. Okay, and I would like to add seed duration, course duration also. I have extracted what exactly the data that I required. Got it? Select CNAME, course name, course duration from courses where the course name in Java, Oracle, Mongo database. Understand the way or the kind of querying pattern? Okay. If in case like if you wanted to add more of your less than, even like here the case is the values are in string format, hence I have used the in operator. You can use less than or greater than, LTE, GTE. Okay, we can always use them. So first of all, what is indexing? Why we need indexing for a database, and what are all the different types of indexes, particularly that are available with the Mongo database. So as we ourselves know, this database is not something like a RDBMS, also which is not a table kind of structure, rather it is a document oriented. So when it comes to the question, what is indexing? Indexing is making the document under respective key value pairs or an object or an array to get remembered by the engine, so that whenever there was a query, the filtering process or sorting process would get faster and easier to access the data. So why we need the indexing for the database? When we have the millions and millions of rows, it is really a tough job for the database in order to pick a one single value out of a 1 million records. So likewise, we need the indexing for the database. So when it comes to the Mongo, what are the different types of indexes that we do have? So prior to that one, we have a couple of definitions here. Let us go through. Indexing. Indexes are considered to be a special data structure that stores a partial part of data from the collection. This partial set of data stores the value of a specific field or a set of fields which might be ordered by a value of the respective field. Also, indexes support the efficient executions of the queries in the Mongo database. So there are a lot of advantages of doing the indexing in order to improvise the performance of an application, to improvise the performance of a query. If you have a collection with hundreds and thousands of documents, it doesn't mean actually millions of documents. And when you wanted to find certain documents from the collection, you require to scan through the entire collection to find the documents. But if you have the indexes in place, which you have already created on the respective data, what exactly that you are requesting, these indexes will be limiting how many number of documents that you have to scan in order to get the data. This is how that you are going to filter. Now there is another, and what if you have too many number of indexes created, then they can affect the performance of the crud operations. Why? Because guys, just listen, when you wanted the engine, Mongo engine, to memorize many things like this, if you keep indexing everything, the storage you are increasing a lot again. So again, you are making indirectly you are making a burden to the Mongo database. Okay, if there are many insert, delete, update operations carried out on the documents, then the indexes would definitely need to change many times. Many indexes, many modifications, so much of complexity upon the collection that leads to again degraded performance. Okay, so finally, what is the bottom line here? We need to do the indexing
based on requirement. We need to do the indexing based on the user activity, what kind of data that they are expecting in general, based on the application, what kind of frequent data that it was requested. Okay, so based on which we have to, that's why in real time, whenever first schema, okay, whenever a first schema was designed, okay, initially there will never be any indexes. Remember, indexes would be prepared only once for quite filtering of all the queries, what exactly that they have been used in the background for the corresponding an application. Then only the proper indexing channels would be created, found, and then be implemented. Now, how do we create an index? So very a simple example in front of you. db dot collection name dot create index of which key that you want, provide it, that's it, you have created an index. How to verify that index? Get indexes. When you say get indexes, it will show you the list of all indexes. How do you drop an index? Give a drop index and give the respective name. Okay, and here it was clearly, it will provide you even the information when you dropped it. It shows you how many indexes were there before this command got executed. Okay, and okay means it's a successful execution. We'll show you that one. Mongo. So there was a connection failure. Maybe it's by the via services problem. Just started the service. Now show DBS, show collections. So db dot detail dot find, you can see here this is the some data. Now if you can take a look at this one, dot pretty. Okay, we have just input it in a different way. Okay, see here, if I want to understand get indexes, how many indexes were there? There is one index which is nothing but a default underscore id. There is another one more index which is relevant with the quantity. But in front of you, I would like to create a new one. db dot, I would like to create a new one. db dot course dot insert create collection. Okay, now db dot course was a db test. db dot course dot find ucmt, just because I did not inserted anything else. Insert course name Mongo, course duration 30 days, course duration 30 days, and instructor. Okay, so I was missing here one more thing. So if you can take a look at this one, I've inserted something. So here I have data which I have inserted. So you can see name, course duration, and instructor data. Now what I wanted to give is, see, now I'm trying to check this one document. I wanted to show you how many indexes are there. Get indexes. See how many indexes are there? By default, only one index. That index is nothing but underscore id. Okay, and also let me tell you one more thing, guys. You cannot drop the underscore id index. Okay, you cannot drop the underscore id index. Now let me show you one more thing here. I would like to create an index on the course name. Yes, it's a document ID. Exactly. All the underscore ID references, this all the underscore ID references of object IDs will be memorized. Okay. So db.course dot create index of name is equal to 1. Completed. Done. We created. See, there is some information over here. Created collection automatically. No, it's not. False. Why? Because we have created this collection, and the number of indexes before it was 1. Number of indexes after it was 2. Now, what are the total indexes? Get indexes. See, now we have the 2 indexes. Okay, this is 1 index. This is another index. Name colon 1. See, n indexes was 2. Okay, that's it. You can take a look at this one. Get indexes. There is only 1 index. Okay, so let us take a look at this one. Types and properties of indexing. This is very important. There are different types of indexes. Just now what we have seen is a single field index. One represented, Narendra, confirmation. Okay, confirmation of creating an index. Okay, there will be a kind of sorting methodology, okay, which 1 and -1 I have showed you earlier. Likewise here, a single field indexes, compound indexes, multi-key indexes, geospatial. Now if you can take a look at this one, single field index is something when you wanted to create an index on a single field of a document in a given collection, then it is called a single field index. So you can traverse that in either ascending or the descending order. So for a single field index, you can sort the operations, and what order of that index key doesn't matter. Okay, it can have the sorting pattern in either 1 or -1 way. This is the next one is in a compound index. When you see a query is constantly trying to hit both name and city together, then it is always expected to create a compound index. The compound index, which is going to be indexing on the multiple fields that contains name is equal to 1 and city is equal to 1. Okay, and you sort, this will be sorted based on this. So the index would be sorted the first name and then the city. Next, multi-key indexes. When you have compound and multi-key, many people used to get confused about this, most of the cases. Here, when you say multi-key indexes, a key, whatever, when you are using to index, where the values that always stored in the arrays, remember this one. Okay, a multi-key indexes are used for indexing the values which are stored in the arrays. Okay, then we will use the multi-key indexes. Mongo database will create the multi-key index if there is any indexed field is an array that can hold both scalar or nested documents together. Don't consider this example. Why? Because this example does not contain valid and true nested or array based values. Okay, but the creation methodology is quite similar to what exactly the compound indexing as we have seen. Next one is geospatial. Geospatial indexes, this is to index information, longitude and latitude. There are a number of indexes and querying mechanisms of the geospatial information. So this coordinates again, here we need to support to understand two different types of geospatial indexes. One is 2D indexes, another one is 2D sphere indexes. Okay, what is the difference between the 2D indexes and 2D sphere indexes? 2D indexes. When it comes to the 2D indexes, 2D indexes support queries that calculates geometries on a two-dimensional plane, whereas 2D sphere is something just like an earth-like sphere, means a 3D kind of structure, but it is 2D only. Mostly when you take up the map, okay, Google Map, you will have a Google Map 2D and 3D phases. This is almost little bit same. So finally, I have a couple of more to show you about the indexes. A text index. A text index supports searching for a string content within the collection. That is what you can see. You can always try creating an index by creating name column. It is not just one, you have to observe here. It is the text. What exactly the respective text it was created with. Likewise, hashed index. So MongoDB supports hash-based sharding and provides hash indexes. And these indexes are none other than the hash values. Whatever that you have indexed, the respective indexed key value will be entered into this hashed index. What do you mean by a hash index and what it contains? It will contain a collection of racks or buckets which are organized in an array. A hash function maps index keys to the corresponding buckets in the hash key. This mapping of index key to the respective position in the hash index. This is what it is going to do. Next one, properties of indexes. There are 4 different types of properties of indexes. Unique indexes, partial indexes, sparse indexes, TTL indexes. Let us try to understand very brief about this. Unique indexes. See, this kind of index where the Mongo database used to reject the duplicate values for the respective indexed keys. Okay, so this is more or less like kind of a constraint also. Next one is a partial indexes. This property will index the documents that match the filter only. Okay, means cross verification. That's nothing more than that. If we are building an index with some conditions applied, then it is called a partial index. Okay, and next one, sparse indexes. This property ensures that the index only contains those documents which are having indexed field. The index will skip all the documents that are not a bit confusing for you. When I am just talking about this definition, TTL indexes, total time to leave. See, more or less, I should say one thing. These are something like a constraints actually, okay, properly to be called. And total time to leave, TTL. Indexes are used to auto delete the documents from a collection after a specific duration of the time. Okay.
Well, what is SQL? Guys, SQL stands for Structured Query Language, and it is one of the standard languages which is used for accessing and manipulating relational databases.
Just a quick info, guys. Test your knowledge of MongoDB by answering this question. In which of the following is MongoDB written in? A. C++, B. Go, C. JavaScript, D. Python, E. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
But then when we have to talk about the overall scope or the overall goal of the language such as SQL, well, it has a very simple goal. So the goal of SQL is actually very simple. It is to make sure that it gives the user a very easy way, a simple way, yet a powerful way to access the data while storing it and working along with it at the same time. So when we have to talk about how SQL is used, well, SQL is basically used with a lot of data sets to actually store and work with the data. So all this data has to be generated, right? So step 1 to working with any databases is to make sure that it actually has the data. So after the data has been generated, it gets queried using SQL. So querying is the process where the programmer types in SQL queries, which basically, is used to create a database, create a table, alter the table contents, and in fact even delete all of the contents as well. So there are multiple queries out there. But it has to be known that everything from the most simplest query all the way till very complex queries are actually very powerful in the world of SQL. Data can eventually be stored in a very structured way, and it can be accessed very easily and very nicely just because of SQL. It ensures that the data can be worked on at effective pace. And in fact, coming to the quick comparison we're going to have between SQL and MongoDB, which is going to start right now with the first point, which is the meaning. Well, with the meaning, when we have to talk about it, SQL databases actually involve handling a lot of data by making use of a model, what we call as the relational model. And this relational model makes sure that the data is related to one another, and it can be accessed and worked along in a very simple manner. And this goes for the same when we have to talk about storing the data and processing the data at the same time. But then when we have to talk about MongoDB actually makes use of a non-relational database. So a non-relational database is usually document-based database where the data is actually not interlinked to each other, and this is how basically it works when we have to talk about MongoDB versus SQL. Then coming to the second point, it is the languages which are supported. So SQL is actually the primary language when we have to work with any relational databases. There are multiple flavors of SQL that moves around. There's Microsoft SQL, Oracle's SQL, and many others. So all of these are varieties of the same base foundational concept of SQL. But then when we come to MongoDB, MongoDB actually supports querying in JSON, where all the data is stored. There are actually two formats in which it is stored, JSON and BSON, and this is mostly used to work with the data indirectly and directly as well. So coming to the third point, we have data storage. In data storage, well, as I told you, SQL actually involves storing data in databases by making use of tables, by making use of interlinked storage methodologies. But then with respect to MongoDB, since it's a NoSQL database, it's going to store the data as key value pairs and collection based databases. So this is one of the most important differences when we have to talk about SQL and in fact MongoDB at the same time. So coming to the next point, which is foreign key. So, SQL actually makes use of keys to map each table to another, or say, for example, a column to another column in another table. So when we have to map values from one table to another table, we use something called as keys. We have primary keys, we have candidate keys, we have foreign keys, and much more. So SQL actually supports making use of these foreign keys for various database operations when you have to talk about it. Well, when you have to come to talk about MongoDB, well, MongoDB does not support the use of foreign keys when we have to talk about storing data in databases. Then point number 5, it's trigger support. So SQL ensures that there is a valid support when we have to make use of triggers, because triggers, again, at the end of the day are, a special type of stored procedure which will automatically run whenever an event occurs when we have to talk about the SQL server or wherever the database has been stored. So these triggers keep running and they run a procedure for us, which pretty much is already ready to execute, and in fact it has already been compiled. But then when we have to talk about MongoDB actually does not allow the users, does not allow the flexibility of making use of procedures, stored procedures and triggers. And coming to number 6, it's schema. Well, again, SQL databases contains a predefined schema which ensures the user can work with fundamental structured data. But then MongoDB actually does not contain a structured predefined schema. It goes on with a dynamic schema, and this dynamic schema has been the gold standard of working when we have to talk about all of the big NoSQL databases present today. And then coming to point number 7 is the best fit. Sometimes SQL is not the best fit when we have to talk about hierarchical data storage, because again, storing data one after the other, where it might become cumbersome and inefficient to go on to work with it after some point of time. But then MongoDB shines here, because MongoDB in fact is one of the best fit when you have to talk about hierarchical data storage methodologies. Coming to number 8, it's scalability. Again, SQL databases can be scaled vertically on top of another, just like a stack, just by increasing the RAM of the system. But then when we talk about MongoDB databases can actually be scaled horizontally by adding more servers in parallel to each other. Again, the outcome of this difference actually differs from what your company wants, because vertical scalability is something which is required at one point of time in an organization, while horizontal stability and scalability is required by adding more servers to ensure redundancy is controlled, the data is there data backups, and the data can be accessed quicker than usual. So again, coming to a quick comparison in this scalability point, each of these has a stand, but then we had to mention this point because SQL is known for vertical scalability and MongoDB is known for horizontal scalability. Coming to point 9, it's the basic working. While SQL emphasizes on certain properties we call as the ACID properties. A stands for atomicity, C for consistency, I for isolation, and D for durability. So the entire basis of SQL is based on these properties to make sure that the database is relevant and easy to work with, and at the same time very low in redundancy as well. But then when we talk about MongoDB goes on to use something called as the CAP theorem. C stands for consistency, A stands for availability, and P for partition tolerance. So all of these again are the driving force behind MongoDB and SQL, ACID for SQL and CAP theorem for MongoDB. And each of these points, when we have to talk about it, adds a certain uniqueness, adds a certain value to the entirety of the theorem, and eventually the working of the database as a whole. Then coming to point number 10, it's external support. As we already know, SQL has been there for a while now, and that it has excellent support, because every time there is an SQL provider out there, there are many vendors out there who provide support for this. Because at the end of the day, SQL, as I told you, there are multiple flavors which can be accessed through, which can be worked with, and at the same time, all of these flavors are about 70 to 80% the very same. So if you come to know one of the flavors of SQL, it will be very easy to adapt and learn the other thing as well. So it has excellent support when it comes to this. Then coming to MongoDB actually has good support too, because when you have to talk about it, MongoDB entirely relies on the community support, and in fact it gets amazing community support. And this is the entirety, and this is the center of universe when we have to depend on good support structures with respect to MongoDB, because at the end of the day, the community guidelines, how the community grows out the product and helps people out is what makes MongoDB what it is. So to summarize this quick comparison between SQL and MongoDB, SQL has been a major player throughout the world of IT, right? It has been very vital, and some people call it legacy as well. In fact, I would disagree with that statement, because if it was a legacy application, then it would have totally not been adopted every single time there's a requirement for a relational database. But then when you have to talk about it, the ground reality is that both SQL and NoSQL databases have been there alongside each other in many companies as well. And then coming to MongoDB, MongoDB brings about a very different variety, a very different idea and perspective of storing the data and eventually letting the user work with the data in a very simple manner, in a very effective manner, without much querying, and it makes it very intuitive to work with the database at the same time as well. So what's your take on this? What do you think about SQL and what do you think about MongoDB?
Today we're going to be going over a simple login form using Pythonflask with MongoDB as the database. So let us go over some of the key benefits for Python. So as some of you already may know, Python is a very easy language to learn. Even if you're coming from a non-technical background, you will require a couple of weeks of training just to get started with Python, and then it's pretty easy from then on if you just keep practicing. So it's a very easy syntax to understand. It's very user-friendly in its syntax. So that's why it's very easy to learn. And just because it's easy to learn, it also increases the productivity. So say for a simple mathematical equation, you might have to write like 6-7 lines of code in Java, but in Python you can simply write one line of code in Python, and you can simply be done with that prospect altogether. So obviously because of the increased speed in your coding, it will also increase your productivity. And then Python is an interpreted language, so that means it compiles the code line by line. So basically that means that so if there is an issue, it will basically wait until that line is resolved. So that is why it's an interpreted language. It's free and open source, so it's there is no licensing fees attached with Python, and it's open source. So you can basically look into the code base for Python itself and try to make some modifications or improvements on your own as well, to tune it according to your needs. And then obviously at the end of it, there are abundant libraries. So every prospect imaginable, every use case imaginable for a coding language, Python already has a library for that. So a lot of libraries already there. So no need for immense amounts of coding just to get a particular use case done. And then eventually, just as I was saying earlier on, there are a lot of use cases for the libraries that Python has. So one of the use cases is web development. So as we can see on the screen, there are some frameworks that are mentioned. These are some of the many frameworks that are there for web development in Python. So there are some full stack frameworks like Django, TurboGears, and Web2Py. So these frameworks implement both in the front end and the back end. And there are some lightweight frameworks as well, like Python, Flask, and Python Bottle. So these are some of the frameworks that are used for lightweight tasks, for minor server deployments, where a lot of complex things are not really involved, but you just need to implement a website anyway. So you would use some lightweight services for that, lightweight libraries for that. So Flask is one of those. So talking about Flask, we can now really get into how Flask is actually working. So as we can see, Flask is a lightweight WSGI web application framework. It is designed to make getting started with web development quick and easy. So you can scale up no matter the complexity of the application that you may have.
Just a quick info, guys. Intellipaat provides MongoDB training mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
You can scale it up using Flask easily. So it's basically an abstraction from the complex intricacies involved in web development. So even a beginner can get into Flask and implement his own web application. As we can see on the bottom of the screen as well, as we saw above, that it is a WSGI application framework. So what does that mean? So basically, there are versions of WSGI in Python. So all of the web frameworks that are present and available in Python, they are compliant with WSGI. So it's a simple calling convention for web servers to forward requests to web applications or frameworks that are written in the Python programming language. So it is valid for a plethora of Python programming languages, the frameworks that are available like Flask and other frameworks as well. So what are the advantages of Flask and why should we use it? So other than the fact that it's easy to understand, and if you want to basically have an abstract view of getting into web development and easy server deployment, you can get into Flask. So the other features would include a built-in development server and fast debugger. So while you're developing your code, you can look at how it's functioning live. And there's a debugger also involved. So you can look at all the errors that are being accumulated in the development phase and resolve it in the moment itself. There's RESTful request dispatching. So all of the post methods, all of the get methods, the standard norms that are followed for requests and responses are followed in Flask as well. There are methods for those to be implemented. There is support for secure cookies. It's Unicode based, so it's the encoding character encoding standard is uniform, and it's basically acceptable by all web browsers and devices. It's WSGI 1.0 compliant. So the current version of WSGI is 1.0.1. If anything is 1.0 compliant, it basically works for later versions as well. And it's easy templating is available for Flask. So that means that mathematical functions and other functions as well, there are templates that are already available in Flask that help you to implement these without actually having to write the entirety of the code for that. And there's integrated support for unit testing. So you don't need to install any third-party application for unit testing, as Flask provides integrated support for that. So you can test using the methods available in Flask itself. So these are some of the advantages that Flask has and why you could choose it as your platform for web development. So if we look at the syntax that is provided for Flask, we can see that there are minimum lines of code involved. So you can basically deploy a web server with the absolute minimum lines of code possible. So if you were doing this using Node.js or Express.js, or if you were doing this any other framework, you would have to write a lot of lines of code basically to deploy your server. But with Flask, you can simply create a variable that, as we can see in the screen, we've created a variable called app. We've equated it to a new Flask app. So that is all basically that we have to do in order to basically create an application, a Flask application, and then we can simply run that application to deploy our server. So these are some of the things that make Flask a very lightweight language from a coding point of view, where you don't need a lot of developmental skills to actually get ahead in that particular domain. So we'll look more into the syntax during our hands-on section as well, but that was just to give you an idea about how easy it is to get started with Flask in the first place. So let's look at how easy it is to actually deploy a website by a little bit of hands-on. So I'll just show you that. So as we were discussing earlier on, we're now going to get into how easy it actually is to deploy a website using Flask. So without any further ado, let us just create a folder within this. We'll call this folder, we'll call this templates, right? Because we're going to be needing a template HTML. And we're simply going to open up a terminal right over here, right? So you can open that up, and the first thing that we need to do is actually install the dependency that is required, that is Flask itself. So simply type in pip install Flask and it will do everything for you. So as we can see, a Flask is already installed on my end, but if you do it for the first time, then it will install on your system as well. So let us simply create a Python file. So I'll simply click on new file and I'll call this web server .py. So that .py is a Python extension. Once you do that, Python file will be created. So for this purpose, for the rendering of an HTML page, all you need to do is import certain package, certain module from Flask. So we need Flask out of that, and render template. So these are two modules that we require out of Flask. So I forgot to add the from over there. So this is what we will be needing in order to just deploy a simple HTML page onto a Flask server. So after we've done that, so let us now create a HTML file for us to render. So simply click on the templates folder, and within the templates folder, right click on it and create a new HTML file. We will call this file sample.html. Expand that. After you've expanded it, you can simply type in a simple HTML tag. So let us just create it, an h1 tag, and within that h1 tag you can write this is a sample website and save that. So we've now created our dummy HTML file. So we need to now render it. So simply open up your web server Python file and name your app something. So I'll name this as the same name as the Python file that it is located inside. So for that, simply call in Flask and name. So after we've called that, we've now successfully created our Flask application. So we now need some routing, right? So the default page for any website is the index page. So we will just simply do that. So we'll create a function for us to load the index page. So app.route. And within this, simply given the directory. So if the index page is the default page for your website, you simply give in a single slash. And then you create the function that you need to create. So def index. Open that up. And within that, after giving some indentation, you can now give in your return render template and given the name of the web page that you want to load in. So sample.html. And now we can simply call this function and be done with actually hosting our website on a local server at least. So the first thing that we will check is if the name is equivalent to main. And if that is true, which means that the code that we are about to run is the actual driver code for this program. If that is true, simply create some secret key for your app. So this is for encryption purposes. Not a bracket over there, just a string value, a random string value. We can call this secretive key. And the name of the new file, which is web_server.py. So there's an issue. Oh, we didn't actually use double equals to over here. So that was the error that we had. So now that is resolved. So we shouldn't be facing any more errors now. Let's enter, and that would deploy the website onto this particular address. So let us now check that. So once you have actually opened up the address that was mentioned in the command line terminal, so you'll get something like this. So the HTML page that we created has now been rendered, and all of that was done using minimalistic lines of code and a pretty convenient and abstract server deployment at that. So this is one of the advantages that you get with using Flask as opposed to basic Node.js or any other web development framework. So since we're going to be creating a login form, we also need to be storing some information, right? So we need to store the username of the individual who tries to log into the website. And we need the password for that username for the person who's trying to log in. So these two things, they cannot be stored temporarily. We need to create a database in order for us to store that information, right? So what are we going to use? We're going to be using MongoDB. So MongoDB is a cross-platform document-oriented database program. So a lot of complex words. So basically means that there are JSON-like objects that MongoDB uses as its data tuples. So say the traditional way of implementing databases is SQL formatting. So SQL has tables. Tables have columns, and those columns have their respective values in the column, and the rows are called tuples. So that is how SQL works. So, but the thing about SQL is you need to have these tables already created. But a lot of times what will happen is, say if you're working with a web application, you might not know the actual format of the data that is being sent by this website. So you cannot preemptively create a table, right? So the static table creation is not possible all of the times and in all of the use cases. So there is a solution for that, and that solution is MongoDB, right? So MongoDB is basically a NoSQL database program. So as it says in the name, it's a NoSQL database program. So it's not dependent on SQL being a factor for it to store data. So what you can do now is create your databases and create your tables on the go, or what we would call as equivalent of tables on the go, right? So what the data as it comes, as it registers into the database, it will basically create the collections that are corresponding to that data by itself, by assessing how the data looks. So that is one of the advantages of MongoDB. And other advantages would include that it's schema-less, right? So SQL tables do not need to be implemented. So that way you can basically create new columns, new tuples very easily, dynamically. So dynamic database and table creation is also one of the advantages. And that also makes it easily scalable, since you don't actually have to preemptively create a new table or a new table format for storing new categories of data. If, say, a new feature comes up that you need to classify as well, then in an SQL table you would have had to create another column. But in MongoDB, that new attribute, whenever it comes in, the column, or say the collection for it, will already create itself as the data is coming in. So the data is also in the form of objects. So the distinction that you can create between an SQL table or and a JSON object would be that JSON objects are very easily readable by object-oriented programming languages such as Python. And SQL tables, the data that is returned by SQL tables, unless converted into a JSON format, they basically aren't that well read. They aren't that well interpretable by object-oriented programming languages. So these are some of the advantages that you get with MongoDB.
Just a quick info, guys. Test your knowledge of MongoDB by answering this question. Which of the following represent column in MongoDB? A. Document. B. Database. C. Collection. D. Field. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right, so let us now get into the project that we have, which is the login form. So the libraries that we're going to be using are very few and essential to our project here today, because the first library that we are using is Flask for our Flask purposes. And the second library that we are using is Flask PyMongo, which is the connector between a Flask framework and the MongoDB database, right? So without any further ado, let's get into the project. So let us now create an actual login page with some backend functionality as well using Flask. So before we actually begin, there are already 3 HTML files that I have created for this specific purpose with the post function already there. So you can simply download these sample HTML files from anywhere basically and use their post functions for your implementations as well. We're not going to be focusing too much on HTML in this session. So the resources that are required for this particular front end have already been imported into our project beforehand. So we'll close those up because we wouldn't be dealing with them in this project. We'll only be using these names that you can see, the index, the layout, and the register page that would be required if you're creating your account on the login page for the first time. So we'll close those up. And as you can see in my Python file, I have the URL for my MongoDB server. So you can create your MongoDB server anywhere that you would like and copy your URL from there and use it for your database purposes in whatever Flask project you do. So we're going to be using Flask PyMongo for this, because Flask PyMongo is the intertwining element that is required for us to connect our Flask server with our database, our MongoDB database. So that is what we're going to be doing. So firstly, like before, simply import your Flask elements that are required. So we will read Flask. We'll obviously need render template, because we will be rendering the web pages. And then we need the URL for, because we're going to be using the URL implementation in order for us to jump from web page to web page. We'll need the request. We'll need the session. And we need the redirect. So all of these things are already implemented in Flask, so you don't need to write specific code for it. So one of the key advantages again. Then we need our connector, that is connecting our Flask with our backend database. So Flask underscore PyMongo is what we're going to be using. And we're going to be importing PyMongo from that. So our connector has now been imported. And another thing that we can implement, this is optional. If you're trying it for the first time, you may not need to implement it, but say if you want to encrypt the password, so you can use simple bcrypt for that. So I'm going to be using bcrypt. You'll also need to install bcrypt as well, because it doesn't come installed by default. So like before, let us create the app. Now we need to create the functions that basically bounce us around from web page to web page and implement their functionalities. So first thing is obviously for our index page, app.route. Actually, we'll first need to initialize the backend database. So that is easily done using the app.config. So the .config element for our app. So there is already an element in the configuration which is called as MongoDB name. So we can specify the database that we are going to be using. And in our case, it's Intellipaat. And in the second config, we're going to be giving the location, the URL basically, for our MongoDB database server. So you give the URL. And then we simply copy this location that we got from our database and we paste it within the single quotes. Right. So some things you would need to replace in it. So for instance, the password for this particular server that I have temporarily created, the database server, the password is pymongo 1. And the database name is obviously, as we saw before, Intellipaat. So we've now successfully given in our URI as well. So the first thing that we need to do is initialize our connector. So you do that by simply assigning a variable to it. So pymongo, and given the application as an app that we've just initialized with the server location, the database location, and the database name. So the first thing that you will do is create the route for your index. So I'll do this really quick. So we're going to give a condition here. So we're first going to check if there's a particular username. These are the elements that we're going to be adding in our database as well, is in session. Then we're going to return them a message that if they've logged into the website successfully, if they've successfully logged into the login page, then they'll get a message which is basically returning the string. And then we can simply give in the string value of what their actual username is. So this would be picked up from the session object and the username within that session object. And other than that, it's a simple return statement with the render template that we discussed in the website deployment tutorial as well. So in our case, the HTML page that we are trying to access is the default HTML page or the index HTML page. So we're going to name it index instead of sample. Then we're going to press enter and move on to our next routing function as well. So the other page that we're dealing with is the login page. So let us create a route for that. And we'll call this login. And the methods that this particular route is going to be implementing is the post method. So whenever somebody logs in, they're going to actually call the post method and given the details that they've used to log in as. And then let us create the function. So we're just first going to call all the users that are present in our database to check whether the user that we are requiring to log in is actually there or not. So we first store it inside users, and the function call is MongoDB users, which is the collection that we've created for users in our database. And the actual user that we're currently as. So we'll first check for that. By using a search function, which is find_1, and checking if the name matches any of the names that are present in our database. So we're going to pick this up from the request form, which is the web page that we entered it in. So after we've done that, we can now give the appropriate actions for each of the cases if the user has logged in successfully with the right credentials or if he's unable to log in. So for the first case, which is if the login has been successful and this function has returned a true value, we're then going to match the password if the password is correct or not. So the algorithm that we are using, and this is optional, you can use a simple string value as well. You don't need to actually use an encryption algorithm, but it's basically what the norm is for password. So we're using bcrypt. And then we're going to match both of the passwords that are there. So the encrypted password that is present within our database and the password that the user sent. We're going to encrypt it and match it if with the password that is present within our database, so that we are actually authenticating our user. We're going to encode this to UTF. So you wouldn't actually need to do all of this if you're simply using a string value for passwords. So if you're doing it for the first time, it's highly recommended that you go that way rather than memorizing the bcrypt jargon. Then we're going to encode this as well in the UTF-8 format. And then we're going to match it. With the password in our database. For that particular user. So if this condition is true and the passwords actually match, you're actually going to put this username into session as well. So what we're doing right now is simply adding the new username that has just logged in with a successful authentication ID into our session additionally. And then after this successful login has occurred, we can simply redirect them to the index page and give them the message that they are logged in as whatever user they have logged in as. So redirect is a function that is already provided to us by Flask for that purpose only. And we can simply give in the location for that as well. And if this return statement does not happen, which means that the password did not match or the login user was not successful, that it wasn't true, the username did not exist. So we can simply give in another return statement that happens as a fail-safe, which basically means that the user did not exist or if the password is wrong, and return another statement and give them the query, the string output that there was an invalid username and password, or not and necessarily, or password combination. So once you've actually done that, you can now create a page for registration as well. So we can now create a page for if our users want to register into our website. So we can simply do that. And we can call this /register for that. And the methods that this would have is post and get as well, because we also have to check and input both at the same time. So we have to check for if the user already exists, and we're just we're not simply overwriting that registration, and the input would be for the get. So if we're actually changing something in the record, So if we're adding something in the record, we need both of these functions for that. Call this register. So if I was going to check which method has been called for. So if it's post, we're going to first take in all of the users that are actually present within our database so that there is no overlap. And we're going to simply store in a Boolean value whether that user exists or not. By using the find one function. So if there is no existing user, which means that the user name that has been entered in the registration form is unique and new, then we will simply add that entry into our collection. So first thing that we would do is actually take in the password that has been input by the user and encrypting it. We'll encode this into UTF again. And then we'll simply insert the new user into our database. So the insert function is there for that, present in the PyMongo connector. And we're going to add another criteria for this, which is the password. So the password would be the encrypted version of the plain text password entered by the user. And this would be equivalent to hash pass. And then we're going to log in the new user who has just created his account. By simply adding him into the current session. So it would be square brackets here, not round brackets. And then after that is done, obviously we'll redirect this user who has just created this account onto the index page. So simply use the same statement as here. So the same steps as before. So if the name is equivalent to main, we can give some secret key to our app. So we'll call this secretive key again, or why not? And we'll simply run the app. Save this up and this should run without any issues. So there seems to be an error. Okay, so there's an extra bracket over here which wasn't required. So that should probably fix it. Yeah, so that probably fixes it. And now we can simply open up our terminal and run our Python program. So for that, simply type in Python space and the website name. Yeah, so that basically starts our website. So there are certain packages that may not be installed on your end. So if you want to install the connector, which is the PyMongo connector for Flask, you can simply type in pip install, and you can give in the name, which is Flask-PyMongo, and this would install the connector that you require. So the requirement is already satisfied on my end, but if you're installing it for the first time, it will probably download for you. So that would basically resolve this import. And if you want to use bcrypt, because bcrypt is optional, you can use simple string as well if you're doing it for the first time, just to understand the concept of how it works. So if you want to use bcrypt, you can install bcrypt as well with a similar statement. So that would be that. So the requirement for bcrypt is already satisfied on my end. And there's two things more that we need to add, which is the error message in the event of the username already existing. So we'll return a string which says username already in database, and the simple rendering of the page, which would be under the render template register.html. So we do that and we save it. Let us now test the deployed website that we have created for our login. So let us try with a random username. So we'll call this Intellipaat 1, and the password could be anything, 123, and click on login. So as we can see, since there wasn't any username and password with that combination, it gave us invalid username password combination. And if we simply go back and try it again and register Intellipaat 1, and given the password that we want to register it with, so as we can see, we are now logged in as Intellipaat.
Just a quick info, guys. Intellipaat provides MongoDB training mentored by industry experts, the course link of which is given in the description below. So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Hope you all enjoyed the session. Thanks for watching.